So let's say you found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there YouTube, the Dapper Dinosaur here. I recently had a patron poll about what to cover after I finished my recent Genesis Apologetics Should Apologize series. Answers in Genesis won the poll, and since I'm a little burnt out on creationists lying about biological evolution, I picked a video of a creationist lying about cosmogony. So I downloaded AIG's most popular video about anything to do with space, namely Big Bang Exploding the Myth with Dr. Terry Mortensen. Unlike a lot of creationist PhDs, Dr. Mortensen has a legitimate degree from Coventry University in Coventry, England. Anyway, enough with this introduction. As per usual, grab your face protection, beverage, and a snack of choice, because there's a whole lot of stupid to get through.
I'm President and CEO of Answers in Genesis, the Creation Museum, and the Ark Encounter.
And it's my favorite, almost certainly not a werewolf creationist. Seriously though, character idea for a Werewolf the Apocalypse character? You're a werewolf named Ben Cam, who runs a religious scam attraction to bilk the faithful out of money that you funnel back to your pack to help root out vampires. Also, in wolf form, you're a dingo. I know a lot of my viewers are nerds. Make it happen. Anyway, in case you don't know, Ken Ham is the Australian man behind Answers in Genesis, including their Creation Museum and the Ark Encounter, both in Kentucky, USA. He also famously debated Bill Nye a few years ago, and I honestly think they both embarrassed themselves to some degree, but Ken far more than Bill.
Thanks for joining us in Legacy Hall to hear Dr. Terry Mortensen, one of our most popular international speakers.
Oh, you're very welcome, Ken. It's nice to get a break from all the biology and talk about things that don't have a metabolism or genes.
Dr. Mortensen holds a PhD in the history of geology from the University of Coventry in England and a Masters of Divinity degree.
Wait, so not a degree in astrophysics or even astronomy? You know, a PhD in the history of geology, apparently not even the actual science of geology, is exactly as qualified to talk about the Big Bang as any other rando off the street, right? Look, I don't think slinging credentials around is important, and you don't have to have a degree to be right. But I'm not the one hyping the guy's credentials. You are, Ken. And if you're going to hype credentials, maybe you should do it when the credentials are relevant to the topic at hand.
He's traveled to over 25 countries to teach apologetics in churches, conferences, and both secular and Christian universities.
Man, if only he traveled to over 50 countries. Then he'd be right about everything. That's what happens. Once you've traveled enough, you just get to be right. Isn't it interesting how if you are going to be a speaker at a scientific conference in the real world, you're introduced with actually relevant information about you as a speaker that pertains to your talk? Whereas in Creation Land, your introduction is just random facts that have no bearing on what you're going to be talking about? Okay, I'm cutting off the introduction here because it goes on way too long and never becomes relevant.
We look up in the heavens today and we see amazing sights that people didn't see until Galileo turned the telescope to the heavens.
In fact, we see sights that are far beyond anything Galileo could have ever seen. I myself have seen Saturn, Jupiter, Venus, Mercury, Neptune, and Uranus with far better clarity than he could have hoped for. And I've seen nebulae and star clusters he couldn't have seen at all. In fact, here are some pictures taken with my NASA shill phone.
Nebulas and galaxies of all different sizes and shapes and colors. And it's just amazing what we see out there. And then when we get closer to home, we have amazing planets like Saturn and Jupiter, and the jewel of the whole universe is where we live, Earth. How did all those things come into existence?
Well, I'm guessing you're going to say that it came into existence by magic. So it's best not to look any further into it because you have a book, and since you interpret it in a childishly literal way that contradicts nearly all the available evidence, you're going to just lie to us about what the universe is like to preserve your non-explanation of magic.
Well, the dominant view today in the world is the theory of evolution.
No, evolution is a theory of biology. Biology doesn't explain how stars, galaxies, planets, nebulae, or any of the rest got here. You might as well have just said, the dominant theory today is that it all came from Mrs. Robinson's crockpot. You're not even out of your introduction, and you've already lied to your audience. This looks promising.
And you might say, well, now, wait a minute. I thought evolution was about Darwin and how we got plants and animals.
Hey, I did say that. Because it's true.
Well, it is about that. But evolution is really a three-part theory to explain all of reality.
Nope. That's just you doubling down on your lie. The theory of evolution is the one and only theory of biodiversity, and it is only a theory about biodiversity. Perhaps you're confusing evolution with the Big Bang, the nebular hypothesis, star formation, and stellar evolution, which isn't the same as star formation.
And so I like to explain it this way. You have biological evolution, which explains how the first living cell came into existence.
Oh, sure. Why not toss abiogenesis into the mix as if that's evolution too? I've said it before, and I guess I'm saying it again. If you want to criticize an idea, it's important that you know what the idea is. You obviously don't know what you're talking about, but then again, neither does your audience, and I know that these things are directed at believers to keep them inside your childish version of Christianity, and not at people who aren't already in your science-denying subsect.
And how that cell, over millions of years, diversified into all the different plants and animals.
Hey, you finally said something that's true about evolution. Good job. Come to my studio, and I'll give you a gold star.
But then you have geological evolution, which explains how the Earth came into existence from a hot molten ball slowly cooling and developing a crust and evolving an atmosphere, and eventually those rock layers with all those fossils formed.
I think you'll find that that's called planetary formation and geology, the thing you have a PhD in the history of, but not evolution. But hey, why would words matter in science? Words are just noises silly apes make. They don't mean anything.
And then you have cosmological evolution, which explains how stars and galaxies and planets and solar systems came into existence.
No.
That's theories like the Big Bang and the theories of relativity you're thinking of. Also, quantum physics gets in there. None of those are the theory of evolution. It's like creationists don't even want to be taken seriously in scientific circles.
Actually, the evolutionists do use that kind of language. Here are the covers of 4 astronomy textbooks, and they're all talking about the evolution of stars and galaxies.
I like how they are all about stellar evolution, which, contrary to your statement, isn't about how stars form per se. It's about how they change over their lifetime from protostars to stellar remnants. And yes, of all the areas you talked about, this is the one where the word evolution gets used as a technical term outside of biology. I mean, you had to cherry pick to do it, but you scored a point.
And I could show you geology textbooks that talk about the evolution of the Earth.
But you're just not going to, are you?
Here's a chart used in an online course at Harvard University about cosmic evolution from Big Bang to mankind. So the whole story is evolution.
But the word evolution can be used in a non-technical manner. For example, we can talk about the evolution of dance, the evolution of the Schrödinger equation, the evolution of pop music, the evolution of CGI. None of this has anything to do with the theory of evolution. And in none of those cases is it a technical use of the word. Evolution can simply mean change over time of any kind when it's not being used in a technical sense. Your equivocating on the definition of evolution doesn't actually add to your argument that all science that contradicts your laughable ideas is under a single umbrella. It's just you using a logical fallacy, one your audience probably doesn't notice because of confirmation bias.
And that story about origins is based on a worldview that controls science today. It is the worldview that philosophers call naturalism.
No, it's based on methodological naturalism, not philosophical naturalism. And only philosophical naturalism can be considered a worldview. Methodological naturalism is the assumption that allows you to generalize about principles based on the results of past observations and experiments. The other option essentially leads us down the road of Al-Ghazali's The Incoherence of the Philosophers, in which predictions are impossible because rather than following an orderly set of laws as the Greek philosophers proposed, instead all events are actually miracles based on the immediate and omnipresent will of God. So fire isn't hot because it is an exothermic reaction which ionizes atoms creating an area of excess thermal energy. Nope. It's hot because every time there's a fire, God makes it hot. And if he decided to make fire cold tomorrow, that'd be just as reasonable, and you can't predict what he'll do. I can't actually disprove this supernatural idea of unpredictability of the world, but it's easy to see why its adoption in the Muslim world corresponds with those areas of the globe stagnating in terms of science, a condition that still persists today. Methodological naturalism is the only option for science that actually leads to scientific advancement. You can take a halfway house where some things are natural and others supernatural, but it just means that you can only make scientific progress in areas that you've correctly identified as natural. But in areas you may have incorrectly identified as supernatural, your knowledge will stagnate at best, and be forever wrong at worst.
But it's also known by the name atheism.
Methodological naturalism does not equal or require atheism.
And there are two assumptions controlling science today. The first assumption is that nature or matter is all that exists.
Yeah, space-time and energy are made up by the religious types to trick the scientists. But again, we're confusing methodological naturalism with philosophical naturalism.
Now, not every scientist believes that. There are scientists who believe in God. But most scientists do their scientific work as if that's true. So they might believe in God on Sunday or Saturday, whenever they're going to their religious services. But when they do their science, they do it as if nature is all that exists.
So, you do know the difference. I wonder if you'll tell us how we can base scientific principles off the possibility that some processes in the world might simply be magical and fundamentally outside the laws of nature and utterly unpredictable. Go ahead. I'll wait. Probably until I die.
And the second assumption controlling science today is that everything can and indeed must be explained by three things: time and chance and the laws of nature working on matter.
I mean, science is the attempt to explain things in terms of regular laws. There's no guarantee that it will succeed in any given area. The success of science isn't an assumption of science. It's perfectly possible that there's something out there that science simply can't explain because it is not natural. But that's not a good reason to decide that your pet ideas are those things. We have to investigate to find out. And the way we start that investigation is with science, which of necessity uses methodological naturalism.
If you have those three things, time, enough of it, millions and billions of years, chance, and the laws of nature, the laws of physics and chemistry, you can explain the origin of stars and galaxies, the origin of the solar system, the origin of the earth, the origin of plants and animals, the origin of man, the origin of language, the origin of religion. You just need enough time, chance, and the laws of nature.
Well, that wasn't the initial assumption, that all of these things had a natural explanation. Rather, that's how it seems based on scientists using methodological naturalism to find explanations for all of these things and meeting varying degrees of success. For most of those things, yes, the mainstream of science has done an outstanding job. For the emergence of the first life and languages, well, there's still ongoing research. And if you're right about such things being magic, science simply will hit a brick wall. But so far it hasn't. It's just been slow going.
Well, because of those assumptions, the dominant view today regarding cosmic origins is the Big Bang Theory.
Funny how it was actually proposed by a Catholic priest and hailed by the Pope as a vindication of the biblical idea that the universe had a start, rather than being eternal, as had been the dominant idea in physics before that. Was Georges Lemaitre an atheist? I mean, he wasn't your brand of Christian, I get that, but I've never met a Protestant who was so anti-Catholic as to believe that Catholics don't believe in God. I don't know, maybe you're an exception.
And when the theory was, originally proposed in the early 20th century, they talked about this really, really compact bit of matter, energy, space, which some affectionately called the cosmic egg.
The term cosmic egg comes from the mythologies of a number of Indo-European cultures, and it was used in the 1930s to describe the initial state of the universe before the Big Bang. From what I can tell, it's not currently in use for that purpose, but I thought it would be neat to let you know that this is another one of those areas where science naming something doesn't constitute an argument for the religious background of that thing. For example, the cosmic egg of early versions of the Big Bang isn't evidence for the Vedas any more than mitochondrial Eve is evidence for the historical existence of the biblical character of that name.
That developed some kind of instability, and it started to expand, and space expanded with it. That was the Big Bang.
Modern ideas are less enthusiastic about a pre-Big Bang singularity and have largely moved past the idea of the universe existing in a cosmic egg-like structure. But honestly, those points are a bit nitpicky.
Today they don't talk about the cosmic egg because, of course, that raised an important question. Well, where did the cosmic egg come from? And a lot of astronomers and astrophysicists didn't like that question. So now they say, well, nothing expanded into something.
You say that like scientists have switched to that answer because it raises fewer difficult questions than the idea of the cosmic egg. It doesn't, it just raises different questions, but seems to be a better fit with our modern understanding of things like quantum physics. But yeah, it's an area of ongoing research.
And that happened about 13.7 billion years ago. And after a few 100 million billion years, helium and hydrogen gas clouds began to form.
No, that took 380,000 years, not millions or billions of years. See, this is why you don't get a historian of geology to give a lecture on cosmogony. He won't get even the basics right.
And they then developed centers of gravity, and that collapsed and ignited nuclear reactions, which caused the first stars to be born 10 to 12 billion years ago.
No, more like 13.5 billion years ago. At least get the theory that you're arguing against right. It's not that hard. We live in the age of Google. All these numbers can simply be Googled.
And then some of those stars exploded in supernovas, and that caused shock waves in the nearby universe that caused other gas clouds to collapse to form new stars. And our sun was born about 5 billion years ago, and the solar system came from the sun.
No, our solar system formed from the same nebula as the sun, but the sun didn't produce the solar system. It's not like the young proto-suns spat out the planets, moons, asteroids, and comets. They formed in orbit of the sun from particles already in the nebula and gravitationally bound to the center of mass that would condense to form the sun. Additionally, you know you've gone way past the Big Bang, right? Like, the nebular hypothesis isn't dependent on the Big Bang specifically. It was proposed long before the Big Bang and was assumed at first to operate in various eternal universe models.
So that's the evolutionary view for the origin of the cosmos, based on naturalistic assumptions. But not all scientists accept those assumptions. There are scientists who have a biblical worldview.
And the degree to which they hold the evidence to the standard of their pet interpretations of the Bible or any other work of literature is the degree to which they are not scientific. Science isn't based on the Bible. Rather, if you want an interpretation of the Bible that's true, you'd better make sure it doesn't contradict observed reality.
Not a naturalistic, atheistic worldview. And there are two basic assumptions in the biblical worldview. The first is that the eternal, good, all-knowing, all-powerful, holy God exists, and He created everything else.
Something you can believe without abandoning methodological naturalism.
Now that's a very different starting assumption than nature is all that exists. And the second assumption flows out of this one because this God is not silent. He's a speaking God. And He has spoken through one book, the Bible. And the Bible is God's completely truthful eyewitness testimony that explains the key events in history so that we can correctly interpret the evidence from the origin and history of the creation.
And how would you know if you got your interpretation wrong without holding it to the standard of observed reality? You can't. You can only be wrong or right by accident. And let me tell you, there are a lot of ways to be wrong, but not nearly so many ways to be right. So if you can only be right by accident, then chances are you're just wrong.
And so we want to look at what the world actually reveals to us and look at what are the results and how the assumptions of those two different worldviews fit with what we actually observe. But before we do that, we need to just clarify an important word, and that's the word science. You've maybe heard this. Evolution is science and creation is faith.
Well, yes, and it's true. The theory of evolution, as well as the theory of the Big Bang, are science, and creation, of whatever stripe, is faith. But there are versions of creation that do not have to contradict science, and really all I ask is that you not contradict science. Beyond that, I don't really care what you believe for the purposes of this channel. I have my own beliefs, and in some cases lack of beliefs. But I'm not here for that. And really, if you're going to try to challenge science, you shouldn't be concerned with that either.
Or evolution is science and creation is religion. Ever heard anything like that?
I'm not sure that I'd say creation is a religion per se. Rather, it's an important component in various forms in most religions.
The evolutionists love to say that, but whenever I hear that, I know that that person either doesn't really understand science and the nature of this origins debate, or he's trying to confuse us.
Or, and just hear me out here, maybe he realizes that methodological naturalism is the only way to make consistent progress in all possible areas in science, and doesn't appreciate backwards Luddites like you trying to stifle the advancement of science.
Because to understand this origins debate, we need to understand that there are two broad categories of science. I like to call them operation science and origin science.
If you saw the Ken Ham Bill Nye debate, then you'll recognize this distinction as one of Ken Ham's main points. According to Ham, and I suppose his mooks, operational science is about the present and origin science is about the past. Except that that's an artificial distinction. The only reason to assume it is to assume that the past operated fundamentally differently to how the present operates. But that's incoherent, as the present continually changes into the past, and we don't see the present behaving in some chaotic, unpredictable manner from moment to moment.
Operation science is what we normally think of when we think of science. It's also called experimental science or observational science.
Well, since the Big Bang Theory is based on experiment and observation, I suppose it's part of the operational science, even though it's about the origin of the current state of the universe. Good to know.
And it's the science that produces technology, finds cures for disease. It's the science that put a cell phone in everybody's pocket.
I'll grant you that the Big Bang hasn't done a lot to get people new gadgets or cure their ailments, but that's not the criteria for something being true or scientific. Something could be completely useless and totally scientific. Utility and scientific merit are separate things.
And so most of biology, chemistry, physics, meteorology, what they do on the evening news, weather report, engineering, medical research, those are all forms of operation, experimental, observational science. We're studying things in the present.
We're not studying things in the present, though, are we? We're studying how things worked in the past. Because even if you're watching an ongoing experiment, it takes time for the information you're gathering to get to you, and even more time for your brain to process it, and more time still for you to write it down. Because of how the universe works, all observations are necessarily of past events. We don't have access to the present, and the fact that we seem to is fundamentally an illusion. So how far back in the past does it have to go before it doesn't count as observational science? Does the forensics used to solve murders count?
To see how they operate, how they function, whether it's cancer cells or weather patterns, and we're trying to figure out how to predict things, how to manipulate things, how to produce new technology.
You don't see how the ability to predict things relies on the assumption that the laws of the universe operated in the past as they do today, and that they will continue to do so? If that's the assumption of science, which it is, then you can extrapolate into the past just as well as you can into the future.
But that kind of science won't answer the question, how did Saturn come into existence?
Why not? I mean, if we assume the general temporal invariance of how the universe operates, then we should be able to find a model that fits how the universe operates that can explain the formation of Saturn, assuming it formed naturally. Then, test it by looking to see if the predictions of that model fit both new information about Saturn, as well as fit what we might see in other star systems, which conveniently we can now learn about. And of course, if Saturn got there by magic, and couldn't form naturally, then no proposed model of natural formation will actually fit the facts of Saturn as they are observed now, and observations of exoplanets will not correspond to predictions of that model.
Because you can't recreate Saturn in the laboratory. It's there, and you want to know what happened in the unobserved past to produce that planet, to produce those rings.
Right, but you can look for extrasolar systems where planets like Saturn are forming. You can look for confirmed predictions in modern Saturn and its rings based on your model of Saturn's formation. And if your predictions are wrong, then so is your model. Odd as it might sound, we can make predictions about the past and confirm them in the present.
That's a historical question.
You might not know this, but I actually have a degree in history. And trust me, the formation of Saturn is not a historical question. History deals with the records of humans, particularly their written records. So unless there's a hidden record of humans watching the formation of Saturn, then it's not a historical question. And even if your interpretation of Genesis were true, it's still not a historical record of the formation of Saturn specifically, so it still wouldn't be a historical question.
And so for historical questions, we need what I call origin science. And that's also sometimes called historical science. And historical geology, trying to figure out the history of the earth. Paleontology, studying fossils. Paleoanthropology, studying human fossils. Paleoclimatology, trying to figure out what was the climate like 1 million years ago. Archaeology, cosmology, and forensic science. That's what police detectives do, trying to solve the question, why is that dead body in the living room?
You had historical geology, paleontology, paleoanthropology, paleoclimatology, archaeology, cosmology, and forensic science up there. I guess not actual history, though, since it's none of those things. History gets no love. So none of these sciences are based on observations in the present and predictions about future data, huh? That'd be news to everyone working in those fields. In fact, I've gone on at length before about predictions made and confirmed for hundreds of years in paleontology. Seems like you're just picking on these sciences because they are the ones most at odds with your laughably absurd notions about the history of the universe. Also, I love how you're lumping forensics in there, because now that means you're invalidating basically the whole basis for evidence in criminal cases. I guess let's just let all the murderers go.
That's a historical question. These are forms of historical science. And I can illustrate the difference between the two if I think about a car. A car mechanic is an operation scientist. He knows how the car operates. He knows how the pistons go up and down. He knows how the air conditioner works. And if it doesn't work, he knows how to fix it.
Except he's not a scientist, he's a technician. Scientists attempt to expand scientific knowledge. Engineers use well-established scientific principles to design technology and processes. Technicians are experts in the operation and maintenance of various forms of technology. So science flows from the scientist who discovers it, to the engineers who use it to design things, to the technicians who use the designs to actually accomplish things in the real world. These titles are not interchangeable. An auto mechanic isn't a scientist, but that doesn't mean he isn't smart. It does mean that he's ill-suited to your analogy.
But just because he knows how the car operates doesn't mean he knows anything about how the car came into existence.
But the thing is, if the creation of cars were a mystery to him, he could learn about them and make hypotheses that he could test. For example, he could test the material properties of the substances the cars are made of. He could look for machine marks on parts. He could look at how similar items are created, etc. And from this, he could make a hypothesis about the manufacture of cars, and make predictions about what he might expect to find in places on cars he hasn't examined to see if this is correct. And chances are that if he's rigorous enough, he'll get some pretty good idea of how cars, in fact, are created. And while he might not ever get it 100% right, he'll certainly do better than if he just stuck to whatever made-up answer struck his fancy first.
The way the pistons operate doesn't tell you how the pistons came into existence.
No, but the structure of physical features and composition of the pistons can give you clues to it.
That's a question of origins. And so the car manufacturer is the origin scientist. He knows how the car operates, but he knows how every part of that car came into existence.
Again, this is a bad analogy, because the manufacturers are a group primarily made of engineers and technicians. There are some scientists working on things like new ways to improve fuel efficiency or safety, but still, the vast majority of the process of car design and manufacture is not science. It's engineering and technical work.
The question of origins is a different question than the question of operation. We know how things operate, some things about what some things operate in our universe. We know how some things go around other things, some in very elliptical orbits, some in pretty close to circular orbits, and things rotate on their axis. So we know things about how they operate, but the question is, what do people know about origins?
In some cases, a lot. And of course, the story of origins can't contradict how things operate in the present, so that eliminates at least some otherwise possible accounts of origin. But the fact is that, given the current understanding of science, we can and do look at objects and come up with testable, falsifiable, and sometimes confirmed hypotheses about how these things came to be.
So the question of operation is one thing, the question of origins is a different question.
A different but related question, since how things operate in terms of physics gives us information about how things operated in the past and will operate in the future. because nature is predictable, at least in principle.
And we need to understand that all of the scientists, whether they're creationists or evolutionists, they have the same things to study. They have the same stars, the same galaxies, the same planets, the same stardust, the same starlight.
Yup, and where creationists actually stick to the scientific method, they've been known to do good work. In fact, Henry Morris, one of the founders of modern creationism, did good work in hydrodynamics. Of course, outside of that field, he went a bit crazy, as he was laughably wrong and not even internally consistent, like most young Earth creationists.
And if they start with naturalistic assumptions, they come up with a Big Bang and billions of years for the formation, the origin of these things.
What he means is that if they follow the scientific method in the only way that's actually practical and that gives results in every field, they'll come up with things like the Big Bang.
Those who start with biblical assumptions look at the very same objects and they see all kinds of evidence confirming that the universe is designed and young.
And what he means here is that if you disregard the scientific method and just force all data to fit a predetermined narrative, while disregarding data you can't force hard enough, you can come to any conclusion you want. I guess that's not technically incorrect. You can do that. Just don't expect to be taken seriously or for your ideas to ever be validated or make successful predictions.
So we want to look at this, and I want to begin by looking at what the evolutionists know about origins, and then we'll look at what the Bible says about origins.
I'm not sure if that was just a slip of the tongue on his part, but he's right. Scientists, that is, the people he calls evolutionists, know things about the origin of life, the universe, and everything. In some cases, less than they'd like to, but still they know some things. All he has is an interpretation of the Bible that he's not allowed to test, so he can't know anything.
And to keep this simple, we're going to start with our nearest neighbor, the moon, and go farther and farther out into space. So let's consider the origin of the moon. And the evolutionists have proposed several theories for the origin of the moon. They have technical scientific names. I've given them simple names to help me remember and help you.
Now we actually get to some astronomy. And, well, there isn't a theory of moon formation. Not even one. Never mind 3. But the most likely hypothesis at this point is that the moon formed from ejecta resulting from a collision between a newly formed Earth and a body about the size of Mars, which has been dubbed Theia after a titan from Greek mythology.
One is the sister theory. The idea here is that when the Earth was a hot metal ball spinning on its axis, No, that's not the one. I just got confused. No, the sister theory is that as there were rings around the sun, 2 centers of gravity developed in what is now the orbit of the Earth. And the material got pulled in around those 2 centers of gravity. One of those centers of gravity eventually became the Earth. The other became the moon. Nobody ever saw that happen.
Nope, no one did. And we have good reason to think that that's not how the moon got here. For example, it has trouble accounting for the relatively large amount of angular momentum in the Earth-Moon system, and it doesn't explain why the iron core of the moon is so small. So, scientists made predictions based on a model of the past, and present observations have largely disconfirmed the hypothesis. It's almost like they're doing observational science about the past. Also, for the record, this is called the accretion hypothesis, a name that actually describes what's being talked about.
Nobody ever did a scientific experiment in the lab to show that that happened.
First, a laboratory isn't required for science to be done. Meteorology and astronomy come to mind as 2 major sciences that you've already accepted as science that generally don't do lab experiments due to the scale of the structures being observed. That being said, I can guarantee you that people built simple physics simulations and ran them to see if the hypothesis was viable. That's an experiment.
People were speculating about the unobserved past to explain the moon that we see in the present. But there were lots of theoretical problems with that, as well as no observational support, so that theory has been discarded.
If you know it's been discarded, then why are you bringing it up? Also, the very fact that the hypothesis has been largely disconfirmed is evidence that scientists aren't just creating a narrative to fit their beliefs. If they were, they wouldn't have discarded the hypothesis when it was disconfirmed. I sense some projection, since it is in fact the creationists who think that discarding their disconfirmed hypothesis is a bad thing.
Another one is the wife theory.
This is actually the capture hypothesis. Again, a name that's useful and descriptive.
Now, this doesn't actually explain the origin of the moon, but explains how the moon became the satellite of the Earth. The idea is that the moon was floating through the solar system. It came close to the Earth, and the Earth looked up at the moon and said, "Hey, I really like that lady." And so the gravitational attraction of the Earth pulled the moon into orbit.
And the biggest problem with this hypothesis is that it's just not really possible. Gravitational capture can be a thing, but it's essentially impossible without at least 3 bodies. With only 2 bodies, gravitational interactions will generally result in either a collision or a trajectory change for both bodies as they exchange angular momentum. In fact, let's see an example using Kerbal Space Program, which is a game that uses a gravity simulation to simulate spaceflight to demonstrate why capture is unlikely. So I put this sort of cheaty spaceship on a flyby course of Dres to show you what happens when you have a close encounter with a gravitational field when there's only one real thing affecting the gravity. So all Dres is just a rock in space. So as we fly by it, we're going to start to curve towards it, but then we're going to fly away again. So here we are on very close approach. You actually get pretty close to the ground, but there's no air, so it's safe. And then we just fly away. That's one of the reasons why the capture hypothesis for the moon doesn't really work, because if something came really close to the Earth like that, why would it enter orbit? It wouldn't. It would just fly away. But next we're going to actually see how you can capture. So I sent the same ship with Valentina Kerman, our brave Kerbonaut, on her way to Jool. Now, Jool is a gas giant, which is sort of analogous to Jupiter. So you can see here that she's coming in, and she's going to encounter Tylo, which is a moon of Jool, and that will change her orbit around Jool such that it becomes a stable orbit. So here she is, actually getting closer to Jool. She's falling towards Jool in the same spaceship. And you can start to see the moons of Jool going around. This is on some time acceleration because Kerbal Space Program would take far too long to play unless you could speed up time. So right now we're going at like times 100 speed or something. Also of note is the planets in the Kerbal Space Program game are about 10% of the size of normal planets with that gravity. And that's just for gameplay reasons. So now we're starting to see Tylo approaching us closer and closer because our fall into Jool's sphere of influence is going to intersect with a close approach to Tylo. So the interesting thing is we don't get to orbit around Tylo this way. So just like with Dres, we're only going to have a close approach to Tylo. And you can see that coming up right here. So just like before, we come in, we're going to get extremely close, because the closer you get, the more extreme the change is going to be in your resulting trajectory. Now you can see the ground of Tylo. And there's Jool and Lathe in the background. And so now we've flown past our lowest point, and we're now exiting the area around Tylo. And we're going to switch back to the map in a little bit and see that we're actually in orbit of Jool. Now this orbit may or may not be terribly stable. It probably isn't, because it probably will result in me encountering at least Tylo again and possibly other moons. But if that happens, I may end up in a different orbit, and eventually the orbits may either settle out so that I'm in an orbit that tends not to encounter other bodies, or it might just eject me from the whole system. So now you can see I am successfully in orbit. But the reason Valentina volunteered to be in this ridiculous spaceship that doesn't even have any fuel on it is because I promised that she could retire to a beach. So I'm sending her to Lathe. So this is just a fun little bonus. So she's landing near the beach. I say near the beach, but it took me like an hour to run from where she landed to the beach. But you guys don't have to see that. Touchdown! Well, the rocket didn't make it, but there was no fuel on there anyway. The whole thing was just cheating. And here's the run to the beach. Finally got to the beach. Time to put out a flag to commemorate this by. So I want to give special thanks to the developers of Kerbal Space Program, Squad, for making this game, which has allowed me to demonstrate some orbital mechanics, as well as I'd like to thank Valentina Kerman, our brave Kerbonaut, who is home at last by the beach. And she always thought that she would retire to a beach, but just not one on Lathe, which is a moon of Jewel. And here's the view from the beach of the planet. There you go.
Now, nobody ever saw that happen. Nobody ever did a scientific experiment to show that that happened. And there are huge theoretical problems, one of which is if the moon came in towards the Earth like that, it wouldn't immediately go into orbit. It would boomerang off in another direction. So that theory has been discarded. And then there's the daughter theory. And there are actually a couple variations on this. One is that when the Earth was a hot metal ball, it was spinning on its axis, it developed a little bit of a bulge on one side, and as it was spinning, that bulge stretched, and pretty soon it broke loose, cooled, and that became the moon.
This is called the fission hypothesis, and it is entirely inconsistent with the geology of the moon.
Another is that the Earth was bombarded with meteorites and asteroids over a long period of time, and chunks of material got blasted off the Earth out into space. It eventually all got into what is now the orbit of the moon and all got together. Nobody ever saw any of that happen. Nobody ever did a scientific experiment to show that that happened.
As far as I can tell, this hypothesis has never been seriously proposed, so I don't know what he's talking about. But of course, experiments could indeed be done.
And there are serious theoretical problems with it. And so those ideas have been discarded. But there's one other daughter theory, and that is the giant impact theory. And the idea here is that there was an object about the size of Mars floating through the solar system. It slammed into the Earth, broke off a huge chunk of material, and that all got together and became the moon. Nobody ever saw that happen. Nobody ever did a scientific lab experiment.
This is the dominant hypothesis today. It is consistent with a number of lines of evidence, such as it retrodicts the lack of volatiles on the moon, it explains the moon's rather small core, and it is consistent with physical modeling of the objects involved both on paper and in simulations on computers. Time will tell if further predictions of this hypothesis are confirmed, and perhaps it can be raised to the level of a theory.
They're speculating about the unobserved past to explain the moon that we see in the present.
Yes, but science isn't just speculating. It is testing the speculation and throwing out ideas that don't fit the data. That's the important part that makes it science. It's what makes creationism not science. Because creationists don't and haven't thrown out their ideas now that they are known to not even remotely fit the data.
Well, in 2003, Discover Magazine had an article, Where Did the Moon Come From? Now that's exactly the question we're trying to answer. And they said, in fact, the story of the moon's origin is still slim on details. That's a scientific way of saying we really haven't got a clue.
No.
Actually, it's a non-scientific way to say that there is still a lot that we are unsure of, but that we have some pretty good idea of the basic picture of the formation of the moon. For example, if you said that the story of the murder of John Doe was slim on details, that may well mean you know the time of death and have a murder weapon. There's blood splatter consistent with your reconstruction of the crime, and you even have a suspect with his DNA at the scene and prints on the weapon. But exactly why he was killed, how he ended up where he was killed, etc. are still unclear. It's not exactly just guessing, and you have quite a few clues.
Experts are divided over whether the collision happened before or after the Earth had grown to its present size.
Yeah, that sounds like a detail, and not scientists having no clue. Do you really think that this is a serious flaw in the hypothesis? No hypothesis is without its questions.
Hey, I don't want a lot of detail. Could you just tell me, when that Mars-sized object hit the Earth, was the Earth the size it is now or a different size? They have no idea. Well, that was 2003, and you might think, well, that was 15 years ago. Science is advancing so rapidly, they surely know the origin of the moon now.
The pace of scientific advancement isn't even across all fields. There's no particular reason why such a difficult question should have been resolved in 15 years. But then, it also could have been.
Well, they didn't in 2012. In phys.org, new research provokes more questions about the origin of the moon.
Were they questions about the size of the Earth? You didn't say. But anyway, new research is supposed to raise new questions. Science is about the questions. The answers to any question should make you ask even more questions than were answered before.
It's beguiled watchers since before records were kept, and today still it fills poets with pensive musings and scientists with enchanting questions. Where did the moon come from, and how did it get there? Hopefully, new research will one day provide us with a definitive answer. Until that day, though, it seems we will all have to just keep musing.
Yeah, because like lots of things in science, we're not really all that confident yet. That's why there is no theory of lunar formation, just a number of hypotheses, one of which is currently the frontrunner. But then maybe we should just accept that your interpretation of a book is right and stop looking into the matter. I'm sure that's what you're about to suggest.
Well, the evolutionists are musing. Creationists aren't, because we have the word of the Creator himself who told us when and how it came into existence.
Yup, I was right. You've got a book, so everyone should just shut up and stop trying to find answers based in physical evidence. I can't imagine how you think that's a persuasive argument, but then you're not really trying to persuade anyone, are you? You're trying to bolster those who are already persuaded.
But there are problems with all those naturalistic theories. One is that we always see one side of the moon.
Okay, I'm gonna let you finish, but that's not really a problem.
And the reason that we do is because the moon is rotating on its axis at the same rate that it's going around the Earth. And scientists say it is tidally locked. There are many moons in the solar system that are tidally locked, but not all. And Mercury, Venus, Earth, and Mars are not tidally locked to the Earth.
That's true. No planet is tidally locked to Earth. I'm not even sure how that would be possible.
We can be really thankful for that, because if the Earth was tidally locked to the sun, it would be burning on one side and absolutely frozen on the other side.
It is good that the Earth isn't tidally locked to the sun, but it's not really lucky. Tidal locking depends on tidal forces. That is the difference in the strength of gravity between the near side of the body and the far side of the body and the object it's orbiting. These are extremely weak tidal forces between the Earth and the Sun, but the tidal forces between the near side of the Moon and the far side of the Moon are much stronger. You see, the Earth pulls more strongly on the near side of the Moon than the far side of the Moon, so if we assume that at first the Moon did rotate faster than it orbited, that difference would always tug on the near side of the Moon trying to keep it in place, and it would slow down the rotation of the Moon. But once the rotation speed matched the orbital period, the tidal forces would act to keep the periods in sync. Tidal locking is a well-understood process, and it is not a problem for any possible method of moon formation or capture. In fact, it is predicted by just basic Newtonian physics.
Well, there's another interesting fact about the moon, and that is that it produces every few years, somewhere on the Earth, a solar eclipse. And the moon slides right across our line of vision and completely covers the disk of the moon. The reason that it does this is because the moon is 400 times smaller than the sun, but it is 400 times closer to us than the sun. And scientists tell us that there are 181 moons in our solar system, and there's no other moon-planet relationship that produces a total solar eclipse.
Except that, scientists don't say that. Because, hey look, a total solar eclipse on Jupiter. And here's two happening at the same time on Saturn. Why be honest about the things you can see with a good telescope when instead you could lie blatantly about them and say Jesus made you do it? I mean, given the fact that you believe in Jesus, that would probably count as blasphemy.
That looks designed, not an accident.
What about that looks designed?
Is it that currently the moon is almost at the maximum distance where it can still create a total solar eclipse? It wasn't always, it used to be closer, and so it was easier to have a total eclipse, and they used to be visible from a larger portion of the Earth's surface when they did happen. Nothing seems designed about happening to exist at a particular point in time.
We've put men on the moon. We've left equipment on the moon. We've brought back rocks from the moon. We know some things about how the moon operates, but they have no idea how the moon came into existence. So let's see what they know about the origin of the solar system. And as I've already indicated, they believe that the solar system came from a giant gas cloud that eventually evolved into the sun and then flattened out and produced the rings, and those rings became planets.
More or less, yes. And this is the result of gravity, which tends to collapse collections of matter, as well as the outworking of the conservation of angular momentum, which tends to flatten the orbit of objects orbiting a central mass over time. This is because the whole solar system has a particular angular momentum, which, being a vector, has a preferred direction and plane of spin. On average, interactions are more likely to align objects with this direction and plane than to move them out of it. As a result, any cloud of gas and dust with any angular momentum, which is all of them, will tend to collapse and form a rotating disk unless this is prevented. Really, in order to say that this can't happen, you need some pretty groundbreaking physics and attendant evidence to back it up. As it is, though, scientists have observed both star formation in nebulae and protoplanetary disks as predicted. So how about that? Scientists found evidence in the present about predictions about the past. It's almost like they're doing observational science.
And here in aerospaceweb.org, you can see that it's a simple 5-step process. But there are serious problems with that naturalistic theory. One is that the Earth is 70% covered with liquid water.
Honestly, this sounds like someone seeing a car crash in a ditch and seeing tire marks on the road, then remembering it snowed last night and telling the guy with him, "Gee, it looks like the driver lost traction on the ice and slid into the ditch." But then the guy says, "Yeah, but the problem is that his tires are made of rubber, so that couldn't have happened." Like, okay, you're not wrong that the Earth is mostly covered in a thin bit of water on top, but, water is one of the most common compounds in the universe. It covers a lot of objects in the solar system, and it even covers parts of Mars. The only thing special about Earth is that a lot of it is liquid, which, given Earth's temperature and air pressure, is exactly what it should be. I can't wait to hear why you think this is a problem.
It is the only known place in the universe where there's liquid water.
Whoops! Unless you count Enceladus, Mars, Europa, Ganymede, and possibly Ceres. And that's just in our solar system. Since liquid water is common here, and we know that other planetary systems exist, there's no reason to think that there isn't liquid water all over the place. Gee, it's almost like this historian of geology doesn't know what he's talking about when it comes to astronomy.
And liquid water is absolutely essential for biological life.
This might not be true. Ammonia has also been proposed as a viable solvent for carbon-based organic life. It has similar properties to water in terms of polarity, and while it has a lower viscosity and higher density than water, it may well still be sufficiently similar to dissolve the necessary chemicals. The other problem with it is that it is only liquid at very cold temperatures, temperatures where the reaction rate of organic chemistry is quite slow. But that just means that ammonia-based organisms would probably have a slow metabolism. That's not really a hard barrier. Also, liquid ammonia is known to exist on the surface of Saturn's moon Titan, so the existence of bodies with surface ammonia lakes isn't hypothetical. But of course, even if liquid water were absolutely vital to life, it's pretty common.
If the Earth was a little bit closer to the sun, our oceans would boil to steam. If it was a little bit farther from the sun, our oceans and lakes would freeze all the way to the bottom. We're just the right distance from the sun, kind of like Goldilocks.
In fact, depending on things like overall albedo, the Earth could be 5% closer and up to 2.5 times as far away without these problems. If you're willing to let the atmosphere vary, it's possible the ocean could be just fine inside the orbit of Venus. You know, if subsurface oceans are a possibility, then proximity to the sun isn't even a factor, provided we're not too close. What's perhaps more significant is Earth's magnetic field.
Then there's the fact that if we still count Pluto, which was demoted from being a planet in 2006, but is being reconsidered, but if we count Pluto and the 4 inner planets, they're all solid planets. But the 4 Jovian planets of Neptune, Saturn, Jupiter, and Uranus, they're gas giants with a liquid center. You can't land on those planets. That seems kind of odd if it's all the result of a slowly spinning gas cloud.
No.
Actually, that's a retrodiction of the nebular hypothesis. See, one of the things that you notice about the solar system is that there's a sort of density gradient where the denser planets are closer in and the less dense ones are farther out. This is because as the sun ignites its fusion in the core, it creates something called a solar wind. This is a pressure pushing out from the sun as a result of both EM radiation and actual particles of matter ejected in all directions from the sun. Of course, atoms and molecules are affected by this in a manner proportional to their mass and volume, that is, their density. So light things like helium and hydrogen get pushed out to the outer solar system more than dense things like silica, carbon, and iron. But if there is a large collection of mass, like Jupiter or Saturn, it can hold onto that hydrogen and helium because the solar wind is much weaker than their gravity.
The sun is 98% helium and hydrogen. The 3 planets closest to the sun are only 1% of those elements.
Yup, because those elements can't stay near the sun given the intense solar wind there.
They have different atmospheres. Mercury has almost no atmosphere. Mars is very thin atmosphere. Venus has a very dense, hot atmosphere. And Earth's atmosphere is just right for life.
Yes, they do have different atmospheres, which you'd expect given their different masses and distances from the sun, as well as their chemical composition. And Earth's atmosphere may be just right for life, but there's no way we can say that for sure, since our sample size for biospheres is 1. Until we find life somewhere other than Earth, there's no way to say that Earth is especially hospitable, since life adapted to Earth, not the other way around. It's possible that life would adapt just as well or better to other atmospheric conditions.
The planets have different orbits, different speeds of rotation, different tilts of the axis, different numbers of rings or moons. Some planets have both rings and moons, and different atmospheres. In fact, the more they send out space probes, the more they're surprised by what they find.
Are you going to tell us why you're implying that the nebular hypothesis predicts that all planets be essentially identical in terms of physical characteristics? Because as far as I know, it does not predict that.
And then if we still count Pluto, 7 of the 9 planets are rotating in the same direction that they're going around the Earth, around the Sun. But Venus and Pluto are rotating backwards compared to the direction they're going around the Sun.
In fact, Pluto's rotational inclination is a bit over 120 degrees, which means that it rotates in the same direction as it orbits. So once again, you're just flat out wrong about something. But keep going.
Jupiter, Saturn, and Neptune have moons going in opposite directions around the planet. Most of the planets have a tilt of an axis which is roughly perpendicular to their path around the Sun, but Uranus and Pluto are rotating on their sides.
Are you even going to try to make an argument based on this, or are you just going to mention that a few bodies are unusual in the solar system and then pretend that the bare fact that this is true is an argument against the nebular hypothesis?
In a textbook on astrophysics back in 1987, in the chapter on the solar system, we read, "Our brief survey has revealed the structure and content of the solar system." That's just telling us what's there. We can successfully, but the story's not closed. We can successfully interpret many of the observed features, such as the sources of meteorites. However, a plethora, that's a large number, of unanswered questions remain concerning the origin of these features. These unresolved questions prompt tentative answers, which they discussed in Chapter 7. Well, that was 1987. And you might say again, well, that was 30 years ago. Surely they know the origin of the solar system now. Well, they didn't in 2009. Newsweek magazine, or New Scientist magazine, had a cover story. The unknown solar system, the 6 greatest mysteries in our cosmic backyard. What were those 6 greatest mysteries? Well, they tell us in the article. The first one is, how did the solar system form?
The solar system is a product of gravity, and while the exact details are still up for debate, The basics of the nebular hypothesis are quite well supported.
Why are the sun and the moon the same size in the sky?
Because we're alive now and not at some other time.
Is there a planet X?
I don't know, maybe, but that's not really a question that has much bearing on the age of the solar system or how it was formed.
Where did comets come from?
They probably formed in situ in the Kuiper Belt and Oort cloud.
Is the solar system unique? How will it end?
It's unique in that no other planetary system is likely an exact duplicate of it, but it's also not particularly unusual among the planetary systems we've discovered, and it will end when the sun explodes in about 4 billion or so years.
These are enduring mysteries to the evolutionists. And you open up the article and they've got this big full-page picture showing you, again, that it's just a 5-step process for the origin of the solar system. But it's always good to read the fine print, not just look at the pictures. And up at the top it says, we think we know, not we know, we think we know the story of the solar system, but only comparison with other systems can tell us if that story is universal.
First, that level of caution is good science. Science can't ever be sure how something works or happened. Certainty in empirical matters is just not available to us. We are with more and more other planetary systems, and it seems that, the nebular hypothesis is the way it works.
Watch what they just did. They just changed horses in the middle of the stream. They start out saying, we think we know the story, in other words, how the solar system came into existence, and then they switch to a different question. We're not sure whether that story is unique or not.
Those aren't entirely separate questions. If the Copernican principle holds, and Earth is not a privileged location in the universe, which so far it seems to, then the formation of other planetary systems are likely to be similar to the formation of our solar system.
Well, I don't want to know whether it's unique. I want to know whether the story is true. And they don't know.
If the story is unique, then there's a good chance that the story is not true. So they're related, because physics here is like physics out there. Creationists have this annoying habit of conflating ideas together that, while somewhat related thematically, are not dependent on each other. For example, in this case, ideas about the formation of the moon, the formation of the solar system as a whole, and the formation of the universe are not the same idea, and many options for any of them are compatible with many options for the other two. If the nebular hypothesis is badly wrong, it doesn't prove the impact hypothesis for the formation of the moon or the Big Bang theory false. And if there is some great flaw in the Big Bang theory, it doesn't mean that the nebular hypothesis or the impact hypothesis for the moon are wrong. It's kind of like abiogenesis and evolution. Evolution isn't contingent on any hypothesis of abiogenesis, and would even function just fine with a miraculous creation of the first life. Well, maybe now that we're on our 4th episode, we'll actually talk about the subject implied by the title of this speech and my own series.
2011. Scientists tell us we found that the Earth and the Moon, as well as Martian and other meteorites, which are samples of asteroids, have a lower concentration of oxygen-16 than does the Sun. The implication is that we did not form out of the same solar nebula materials that created the Sun. Just how and why remains to be discovered.
You know, I read that article after seeing this bit of the speech. That quotation by McKeegan is in there, but it stands out as not really conforming to the rest of the article. I was curious, so I read other articles like documentation from JPL about the Genesis mission that gathered the sample that was analyzed to reach these conclusions, other 2011 news reports, and even a 2012 paper from NASA going into detail about why the results are the way they are. As it turns out, the Sun is not likely representative of the isotopic composition of the nebula from which it and the solar system condensed, and likely neither are most other bodies. In the case of the Sun, one of the things you might know about it is that in the core of the Sun, the dominant processes are nuclear processes. Nuclear processes result in changing the chemical and isotopic composition of a system. So we should not generally expect a ball of nuclear fusion to keep the chemical and isotopic composition of the material that initially formed it. Another thing is that high-mass isotopes are not evenly distributed outside the Sun, as was implied in the initial article. It turns out that they are more prominent the closer to the Sun one is. Probably because the closer to the Sun, the stronger the solar wind, and high-mass particles are less likely to be affected via escape from their parent body by the solar wind. That's why Earth and Mars have anomalously heavy carbon and nitrogen compared to the asteroids and comets. So, rather than just being some weird mystery that somehow disproves science, this finding was a launching point to discovery and research into the physics of how isotopic fraction does and can occur. Or maybe the fact that 1% of the solar system's matter is different than the other 99% is proof that it formed by magic. Yeah, that's gotta be it.
So they know things about how the solar system operates. They know how some things go around other things and how long it takes to go around other things, but they have no idea how the solar system came into existence.
Well, as we've already pointed out in this series quite a few times, that's not true. So I can just leave you with this.
You're wrong. You're so wrong.
Wrong, 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 wrong. Wrong, 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 wrong. You're wrong. You're wrong. You're wrong.
So let's go farther out into space. What about the origin of stars and galaxies? Well, Steven Weinberg is a world-famous astrophysicist. Speaking at a conference in 1985...
1985? This talk was given in 2018, or at least it was uploaded in June of that year, and given how little work needed to go into it, since it's just an intro by Ken Ham that cuts right to an otherwise unedited speech, and it was put on YouTube via livestream, I think it's safe to say that it's unlikely they waited more than 6 months from the time the speech was given to livestream a copy of it to YouTube. In fact, it was probably streamed live. So this means that this quotation we're about to hear was 33 years old when this talk was delivered. Creationists always seem to be at least a few decades out of date.
Conference of Astrophysicists, he said, among the most important relics are the structures that we see in the sky. That's relics of the Big Bang. Many stars are grouped into clusters. The clusters themselves, along with loose stars like our sun, are grouped into galaxies, and the galaxies themselves are grouped into clusters of galaxies. That's just observing what's there.
Wait, you felt the need to quote someone from 33 years ago just to say that things tend to be clustered in the universe? I know it's nice to have a source for things, but that's not exactly controversial among either scientists or young Earth creationists. Except perhaps the flat Earth or geocentric ones. Are you trying to waste your audience's time and by extension my audience's time?
We want to know, how did it come into existence? A second great disappointment of astrophysics has been that we still do not have a clear and detailed understanding of how these structures were formed.
Oh, so now I get it. 33 years ago, a scientist talked about the mysteries of the formation of the features in the universe. Well, 6 years before your talk, Andrei Krastov and Stefano Borgani published a paper about it in the Annual Review of Astronomy and Astrophysics, titled Formation of Galaxy Clusters. It currently has nearly 500 citations. Why not look into that? Oh, because it turns out that 27 years after your little quote mine, a lot more research had been done, and now we have models for all of these things. And while like all scientific models, they are not perfect, they in fact use present observations, and note, previous models of the galaxy and cluster formations made extremely accurate predictions about future data that were later verified.
Now notice what they don't even know. We don't even know whether the smaller structures formed first and then coalesced into the larger ones, or whether the larger structures formed first and then broke up into the smaller ones. Hey, I don't want a lot of detail. Could you just tell me, did a lot of small things get together and make big things, or did big things break apart to make the small things? They don't know.
They may well have had very little clue 35 years ago, but by 2012, scientists had made many new discoveries, and the consensus is that the initial seeds of galaxy clusters would be in large scale but minor variations in the density of the energy of the Big Bang. Then galaxies formed out of the densest regions, with dark matter being the dominant gravitational component, then as now. So at this point, the galaxies were already clustered to some degree, but then they attracted each other to make the galaxy clusters more distinct. And that's where we are now in the history of the universe, at least according to places like Harvard and Berkeley. But what do they know? In 1985, some dude said it was a mystery, and we all know that 3.5 decades isn't enough time for science to learn anything, so I guess just pretend we can't know how the universe developed, and that means it didn't.
He goes on. It's also a bit disturbing that all these estimates of the ages and compositions of the stars rest on elaborate calculations of what is going on inside.
Is that disturbing? Most of those calculations are based on quantum physics, which is one of the most accurate models ever devised in physics, and it is only more accurate now than it was in the mid-1980s. I'm sorry the guy you keep quote mining finds that disturbing, but if you want to say it's wrong, you're going to have to do better than a decades-old quote. You're going to have to actually have evidence that shows that these models don't or can't work, despite being based on extremely well-supported theories and making testable predictions.
But all that we observe is the light emitted from their structures. And that's still all that we observe.
Pretty much. But light, as it turns out, is a fairly complicated thing. You can determine from the light of a star many things about it, like its distance in some cases, the elements and isotopes of those elements it is made of, whether it has passed through certain kinds of nebulae to get to us, the temperature of the star, whether and how fast the star is coming towards us or going away from us. We can even detect the presence and to some degree composition of planets orbiting those stars, all from the light the star emits.
Well, that was 1985, but here in 2002 you have a photograph of the first star being born. And you can see up in the top left picture, there's a pretty dispersed gas cloud, but you can kind of see that some of that gas and dust is starting to pull together in the center. And then in the top right picture, you can see that more of it is getting pulled in by gravity in that yellow area. And then in the really big picture, you can see right in the center in that yellow area, there's a star being born there. Do you know where that photograph was taken?
It's obviously not a photograph. It's a series of pictures from a simulation. But let me guess. Simulations are bad because even though we have evidence of all these stages, physics describing how such arrangements of matter should act over time, predictions that have been verified, the fact that the timescale involved in those pictures is vastly longer than humanity as a whole has ever been looking at the sky means that all physics, simulation, predictions, etc. don't matter.
This article tells us. It was taken in our universe, and it was in Penn State astronomer Tom Abell's virtual observatory. Do you know where that virtual observatory is? It's in his computer. He didn't see that through a telescope. They've never observed a star born out there in space.
Of course, no one has seen the whole process from nebula to star in real time, just like no one has seen a redwood tree grow from a seed to a 110-meter tree in their lifetime. But that doesn't mean that redwood trees are created by magic, and were all planted by God before you got there, and that some of them just look like saplings. And that now, after you got there to see them, the trees create seeds that will grow to look like what you'd expect redwood saplings to look like, but there's no way those saplings can turn into full-grown redwood trees. Oh wait, that's insane. And it's insane in the same way. But the fact is that even a simple Google search for star birth observation will show that you're wrong, and scientists have in fact made observations of events that correlate extremely strongly to predictions based on models, such as the one you showed, for a star going from the stage of a protostar to igniting fusion and beginning to actually glow as a star.
Well, how did his computer make those pictures? Oh, he programmed his computer according to his assumptions about stellar evolution by time and chance and the laws of nature.
So if I remove all your poisoning the well intonation and phrasing there, you're right. He got those pictures by seeding a physics simulation using the well-established and well-supported laws of physics, and it turns out that the laws of physics work out to show that the nebular hypothesis is a reasonable one, given how physics works. Really, if you want to say that this is invalid, you're going to have to show that the basic laws of physics, such as general relativity and the conservation of energy and mass, the conservation of angular momentum, and the laws governing nuclear processes, such as nuclear fusion of hydrogen, are wrong. Because if they're not, then outcomes like this are the inevitable result of the existence of hydrogen-rich nebulae, which we know exist, and which contain objects that match predicted stages of stellar formation.
They have never observed the birth of a star.
No.
Well, except for all the times they have. But I guess they didn't watch it collapse from a diffuse gas cloud because, no one but me is that old, and it's not easy for dinosaurs to use telescopes.
They've observed death of stars and supernovas, but not the birth of a star.
Again, you're just wrong under any reasonable measure. And since this point has been made better by another, here he is. This is Aaron Rao listing off actual observations of this very phenomenon. A link to his original video will be in the description. Note that he is here responding to Kent Hovind and not Dr. Mortensen, but both men were making the same point.
You mean nobody's ever seen that before earlier this year? I mean, nobody's ever seen that before 2013? I mean, before 2010? Actually, they've been watching this one form since 1996. How many times does something have to happen before you admit that it happened?
Most of the universe's mass is invisible and no one really knows what it is, said Marcus Chown, an award-winning astronomer.
This is true, and it's nice that you went with a 20-year-old quotation rather than a 30-year-old quotation. It's like you're almost caught up, but I'm sure you'll disappoint me later. Anyway, this matter that isn't well known is what astronomers call dark matter. They call it that both because they don't know much about it, and because it apparently does not absorb, reflect, or emit any form of electromagnetic radiation that anyone has been able to detect. Of course, the fact that it has mass and doesn't seem to interact with photons is, in and of itself, things we know about it. But the fact that there are things science doesn't know does not negate the things it does know.
Star formation is shrouded in mystery. Generally speaking, a star forms when a cloud of gas collapses under gravity. That's their belief. They've never observed that. However, if the cloud is too hot, pressure will combat the effect of gravity and prevent the cloud from collapsing. So to form a star, the gas cloud must have a way of cooling down. This isn't as easy as it sounds. In today's universe, this is accomplished by a huge array of molecules which collide and radiate away the heat. Again, that's the belief, that's not observable science.
What do you mean that's a belief, not observable science? Have you ever cooked? That's just thermal conduction. Look, here's a video of thermal conduction cooling down some particles. Why did the water stop boiling and cool down? Well, because it was taken from being in contact with hotter particles to being in contact with cooler particles. So rather than the water cooling the stove started cooling the water. This isn't exactly some kind of controversy. It's the very basics of heat transfer, something that has been roughly understood since humans first started using fire to cook their food. But this pressure problem is not in fact a very big problem, because as it turns out, in space, ideal gas laws don't work. And at the temperatures observed for gas clouds in star-forming regions of the galaxy, there is no barrier to gravitational collapse from heat-caused pressure.
However, the atoms necessary for making all but the simplest molecules, molecular hydrogen, have to be made inside stars. It's a chicken and egg situation. In other words, you've got to have stars to make stars.
No.
The proportion of a star's mass made up of elements heavier than helium is called its metallicity. This is the case even though many of the elements heavier than helium are not metals in the ordinary sense. I don't know what to tell you, except that astronomers are not always great at naming things. So here he is basically saying that to get the metallicity seen in modern stars, you need previous stars to create those elements. He then implies that this leads to an infinite regress, which is obviously a problem. The problem is that metallicity isn't a necessary component of stars. You only use it to make population 1 or 2 stars, but those are stars with high metallicity compared to the first stars. Stars don't need metallicity. They only need hydrogen, and so the first stars, that is population 3 stars, would have been stars with essentially no metallicity. In reality, they'd likely have contained traces of beryllium and lithium, but in such small quantities that it hardly matters. Either way, the fact is that a cloud of hydrogen with a bit of helium and traces of beryllium and lithium can form a star in the same way a cloud with higher metallicity can. Carbon, oxygen, iron, etc. aren't necessary components of stars.
But the question is, where did the first stars come from?
From clouds of almost all hydrogen and helium that formed shortly after the universe stopped being a plasma of unassociated protons, neutrons, and electrons, about 380,000 years after the initial expansion of the Big Bang. And yes, these population 3 stars would have essentially lacked any noticeable metallicity, unlike modern stars.
John Mather, who at the time was at NASA's Goddard Space Flight Center in Maryland and won a Nobel Prize for his work on the Big Bang, says, "We have no direct evidence of how galaxies were formed, how the first stars formed, without the help of the prior generation of stars."
Right, we have to rely on indirect evidence. Like an investigator solving a crime that was not caught on film. There are indirect clues which eliminate some options and suggest others. Then we test those ideas with future data, rejecting options that don't fit the new data until we arrive at one or a few possibilities that are consistent with the data. And, as for the stars forming without the help of the previous generation of stars, I can't say for sure what Mr. Chown, who is the author, means. Mostly because New Scientist is paywalled, and I'm honestly not paying for a subscription to it just so I can read the source of a creationist quote mine that he is presenting instead of presenting actual evidence. There is no particular problem for physics in the formation of the first stars.
How galaxies evolved, whether they were formed from aggregations of smaller units or from subdivisions of larger ones, everything happened in the cosmic dark age. That's between the supposed Big Bang and when the first stars formed.
Again, because this quotation is pretty old, it is out of date. It is now well established how this happened, and since I've already mentioned it, there's no need to belabor it.
It goes right to the heart of the question of how we got here. They have no idea.
What he means is that decades ago they had less idea than they do now, which is to be expected since science is the kind of thing that tends to learn more over time.
But it's worse than that. Not only have they never observed a star being born or a galaxy being born, not only do they not know how it happened, it's worse than that. In 2014...
2014? That's like the future as far as creationism is concerned. This should be interesting.
Neil deGrasse Tyson was the host for an 8-part TV documentary that was shown in many countries called The Cosmos. He is an open atheist, and he was doing a revised version of the series on the cosmos that Carl Sagan did back in the 80s. A few years before that program was featured, however, he said this.
Oh, you're not going to quote something from 4 years before the speech? Instead, you're going to go with 11 years before the speech? Could you use just one source for anything that's less than a decade old? I mean, just one would be nice.
If none of us knew in advance that stars exist, frontline research would offer plenty of convincing reasons why stars could never form.
Yep, and just after this quote mine, he went on to describe how gas clouds coming into contact with each other disrupts their gravitational equilibrium and causes star formation. All he is doing is acknowledging the scale of the numbers involved and the complexities of the physics. It's like the Darwin I quote all over again. Oh, and this section of the book, Death by Black Hole and Other Cosmic Quandaries, can be accessed for free on Google Books, so you don't have to take my word for it.
So not only have they never seen a star born, they don't know how a star is born. Everything that we know says there shouldn't be any stars.
This is exactly the opposite point Neil deGrasse Tyson made way back in 2007. His whole point was to say that even though there are a lot of difficulties understanding how stars form, the fact is that we have made significant progress in understanding just that. And in the 11 years between his book and your speech, even more strides had been made.
But we have stars. So they don't know how the moon came into existence. They don't know how the solar system came into existence. They don't know how stars and galaxies came into existence.
Amazing. Every word of what you just said was wrong.
So what about the origin of the universe?
Exactly. What about the origin of the universe? You know your speech is supposed to be about the Big Bang, right? And we're now at the end of the 4th episode, and you haven't even mentioned it.
Well, I go back to Steven Weinberg. He said, "You may have noticed that despite all these brave words, I have not explained the origin of the universe. The reason, of course, is that this is a matter about which scientists still have no clear idea. It may be that we shall never know, just as we may never learn the ultimate laws of nature, but I wouldn't bet on it."
Well, it's a good thing he didn't place that bet. Turns out that in the 35 years or so since he said that, science did learn a lot more about all of those things.
Well, if I was a betting man, I'd bet big money they won't figure it all out.
Figure it all out? No, probably not. At least not for a very long time. But there's a difference between figuring it all out and having a very good and well-supported model which makes predictions that are vindicated by future data.
Think about it. We have scientists living on this little tiny speck in the universe called Earth around an average sun, which is just a speck in the Milky Way galaxy, which is just a speck among all the galaxies. And these little scientists are going to figure out all the laws of nature? I don't think so.
Right, probably not all of them, but that doesn't mean they haven't figured out what they have figured out. And that's quite a lot. And it's enough to know a lot about the universe and its history. So the fact that humans don't know everything doesn't mean they aren't learning, or that they don't know anything. After this, he just gives another quotation from the New Scientist from 20 years ago. It's the same as all the other ones. Some scientist from decades ago points out what wasn't known at the time. Okay, great.
In 2004, an article appeared in New Scientist, which is a weekly science magazine that summarizes the scientific literature, technical literature for the public.
A third quotation from New Scientists? Did you just dig through their back catalog as your primary form of research for this video? I mean, as a historian of geology, who obviously doesn't keep up to date on astronomy and cosmology, I guess that seems reasonable, but maybe you should do things like look for recent studies in peer-reviewed journals, or even just recent articles in popular science publications. But that probably sounds like too much work to do, and too much like something that might not be so easy to misrepresent.
And it's evolutionist in orientation. They published a one-page article which was also simultaneously posted on the internet. The article was entitled Bucking the Big Bang. It was written by Eric Lerner, but it was signed by 34 scientists from 10 countries.
34 scientists. So almost none compared to how many scientists there were. Got it. Keep going.
All from prestigious universities or science organizations. And I want to read to you a few statements from that one-page article, which is still on the internet.
Okay, this isn't really a point about science, more about style. If you're telling me about some published article and giving me a year and the name of the publication and the author, the only reason you're doing it is so you can read it to me. You don't then have to go on and tell me you're going to read it. I get it. Just read it.
Big Bang Theory relies on a growing number of hypothetical entities, things which we have never observed. Inflation, dark matter, and dark energy are the most important.
Maybe 12 years before this speech was recorded, dark matter and cosmic inflation had not been well confirmed, but that is no longer the case. In fact, it was discovered that galaxy NGC 1052-DF2 has essentially no dark matter, which is evidence that the otherwise anomalous gravity of other galaxies is in fact matter of some form, with properties inferred for dark matter, and not just a misunderstanding of gravity at galactic scales, which is the other option. Cosmic inflation is the current hypothesis to explain the exact levels of anisotropy in the cosmic microwave background radiation. It is fairly well supported. But there are other options, and it is not at the level of a theory right now. Dark energy is just the name given to whatever is causing the observed effect that the current expansion of the universe is accelerating.
Now, inflation. That's not what happens to the U.S. economy.
You mean the value of a currency. Man, at least get the economics right in your jokes. Get something right.
That's what the evolutionists think happened in the first few microseconds of the universe after the Big Bang. That the universe expanded really rapidly in a few microseconds, and then since then, it's been expanding slowly.
Well, cosmic inflation can't be directly observed. It has to be inferred from current data and predict future data. So far, the first has happened, and the second is going fairly well for it, but it's not clear if the current data about this early period of the universe is accurate. Dark matter has also been very reliably observed via its gravitational effects and the lack thereof. Sure, it would be nice to get a jar of it, but so far that doesn't seem likely or possible. Dark energy is really just a name we give to whatever the cause is of the acceleration of the expansion of the universe. The expansion is real, and so whatever is causing it is just called dark energy.
Inflation, dark matter, and dark energy are the most prominent, never observed. Without them, there would be fatal contradictions between the observations made by astronomers and the predictions of the Big Bang Theory.
Which is why they were proposed in the first place. The Big Bang Theory does an excellent job of predicting a lot of phenomena, and so when we find something odd that the current theory doesn't entirely jive with, the most likely explanation is that the theory which is otherwise well supported should be modified, rather than completely tossed out, and with it all the correct predictions and the ability to make future predictions that came with that theory.
An open exchange of ideas is lacking in most mainstream astrophysics conferences.
I can't say whether astrophysics conferences have as free an exchange of ideas as they can or should.
Whereas Richard Feynman could say that science is the culture of doubt, that is because the way most scientific discoveries are made is by scientists questioning what everybody else believes about something. And saying, I'm going to ask new questions, I'm going to do some new experiments, I'm going to explore new ways, I'm not going to believe what everybody else believes about the cause of cancer or how these two chemicals can be combined.
You mean like how people doubted the steady-state universe and came up with the Big Bang based on observations inconsistent with a steady state for the universe?
In cosmology today, doubt and dissent are not tolerated, and young scientists learn to remain silent.
If that were actually true, then there wouldn't be hypotheses competing with cosmic inflation or dark matter. And dark energy isn't even a hypothesis, it's just a name given to whatever the cause of a particular effect is. The fact that there are factions with competing ideas in astronomy and cosmology shows that conformity is not the rule. But you can't confuse agreement on the most well-supported facts in a field with a lack of willingness to consider new ideas. There may well be new ideas competing in the realm of chemistry, but none of them is going to overturn the oxygen theory of fire, that is, the idea that fire is a rapid exothermic oxidation. No matter how much you might like it, chances are phlogiston theory isn't coming back. Similarly, the Big Bang is too well supported to just disappear. The arguments are around the fringe of what's already well established, as it is in all areas of science.
If they have something negative to say about the standard Big Bang model, those who doubt the Big Bang fear that saying so will cost them their funding.
At this point, it should. There just are no longer any real options that correspond with the data other than that in the past the universe had a smaller scale, and that this goes back as far as we can calculate, and that idea is extremely productive in terms of predictions of new evidence and suggesting new avenues of research. We're at the point where you're basically complaining that medical researchers who challenge the germ theory of disease and suggest that ear infections are caused by genies who snuck into your ear while you were using the bathroom are likely to lose their research funding. Yeah, anyone going that much against the evidence shouldn't be funded. And if you want to fund them, then have fun, but don't expect much out of them in terms of actual science.
Well, it might cost more than their funding. It might cost them their PhD if they don't have it yet. It might cost them tenure at the university if they don't have it yet. I know of one professor who lost his job at a major university simply for questioning the Big Bang. He wasn't a young earth, Bible-believing creationist.
You gonna give a name for this person? No? Oh well. Look, if you go against all scientific knowledge in a field, you're going to have a hard time defending your thesis. And so, a hard time getting your PhD. Similarly, if you're not teaching the science, you're going to have a hard time teaching the science as your job, and an even harder time getting tenure. What are the other options? Just hand out PhDs and tenure like candy to anyone who has a crackpot idea that contradicts the whole body of knowledge in the field they want to study in?
You see, what we need to understand is what the scientific world has done a very good job of hiding from the public, and that is that scientists are just like everybody else. They're biased, and they're driven by personal motivations.
That's not a secret or anything that's being hidden. It's the whole reason peer review is so important. I promise, every scientist is just itching to take down their colleagues' papers, especially if in doing so, they can show some well-supported idea to be quite wrong. But the thing is that that's not always easy, and the more well-supported the idea is, the less likely it is that it's wrong and can be so attacked. That's how science deals with bias, by countering it with a frankly brutal process to weed out bad experiments and interpretations that are put forth with insufficient evidence because of bias.
And there's peer pressure, and peer pressure in the scientific community is intense, and it takes a courageous scientist to go against the majority.
There's peer pressure not to be embarrassingly wrong, if that's what you mean.
Well, that was 2004. I kept going back to the website over the next few years for this article. And whereas it started with 34 signatures, or 34 scientists from 10 countries, the last time I looked in 2011, it had been signed by over 400 scientists from over 50 countries, many of them from prestigious scientific institutions, bucking the Big Bang.
So, given that there are about 10,000 astronomers, this would be about 4% of astronomers, assuming all of them are astronomers, which is a stretch. Seems like overall the field does not see a huge problem here.
Well, in 2011, Scientific American had a cover story, Quantum Gaps and Big Bang Theory. Why our best explanation of how the universe evolved must be fixed or replaced. The article was written by Paul Steinhardt, who is the Albert Einstein Professor of Science and Director of the Princeton Center for Theoretical Science at Princeton University. Not a small-time, insignificant institution.
Hey! You're using a source from within a decade of the time of your speech. Awesome. And it appears to be about the fact that at the scales and energy levels of the Big Bang, the fundamental incompatibility of quantum physics and relativity become important. This is a well-known problem, and it is one of the reasons why it is difficult to predict what happened at the very earliest stages of the Big Bang. Of course, no proposed solution has eliminated the basic idea that the universe started in a hot, dense, and compact state, and then transitioned to its current relatively cool, sparse, and spaced-out state. And even better, this article is available in full, for free, on the internet.
The title of his article, The Inflation Debate, with the sub-question, is the theory at the heart of the modern cosmology deeply flawed? Steinhardt thinks the inflation theory is deeply flawed, and he has proposed what he calls a cyclic theory.
So it's important to note that this article is not arguing against the Big Bang. Steinhardt in no way rejects the Big Bang. The inflation he's talking about is the idea of cosmic inflation, in which the expansion of the universe was much faster very early on. He instead argues that given current knowledge of quantum physics, the inflation model predicts an infinitely exponentially expanding multiverse, and that this causes problems for the model from a predictive standpoint. This is in no way a rejection of the Big Bang. It's not even questioning it. But what do I know? I just read the article.
Which, in my personal opinion, is even more ridiculous, because he believes in a series of expansions and contractions of multiple universes over trillions of years.
I'm not familiar with all of his positions, but this is more or less what he proposes. And the thing is that it still involves an expanding multiverse, just one that expands at a more sedate pace and is more likely to result in universes like our own. As far as I can tell, this idea has not become terribly popular, and in no way does it cast doubt on the Big Bang.
But the only universe that we know of is the one we live in. So to believe in multiple universes over trillions of years reveals to me just how bad he thinks the Big Bang Theory is.
Except he doesn't think the Big Bang Theory is bad. He thinks the cosmic inflation hypothesis is inadequate to explain the large-scale isotropy of the universe, but that if the Big Bang occurred in a wider multiverse in which cosmic inflation ends and reverses, then it makes the statistical likelihood of such universes calculable and thereby is a better explanation of the history of the early universe. He even has made predictions based on this, and if his predictions, which are not concordant with the inflation hypothesis, prove correct, then his idea may well start to overtake the inflation hypothesis. So far, it seems that this has not happened.
Well, in the article, he has this chart showing the ultimate growth spurt of the universe, and I want to just expand that a little bit so we can see a little more clearly. Down the vertical, you've got time from the beginning of the Big Bang up at the top, and it's listed in seconds. That's 13.8 billion years. And then across the horizontal, you've got the size of the universe from nothing to its present size. And then you see that line with colors of dots down the chart. And then you see some horizontal lines. And the bottom horizontal line is the limit of direct observation. In other words, they can see only a little bit of that expansion, or if we run it backwards, shrinkage.
No.
Both axes on that graph are not linear, they are logarithmic. So in fact, what is directly observable is a large amount of expansion in terms of actual new space being generated. Now the rate of expansion as a function of size is shown as much higher on the near horizontal portion of the graph, but that lasts, according to the graph, less than 1 second and correlates to the entire observable universe expanding from the scale of less than a nucleon to about a cubic centimeter. The rest of the expansion has continued from then on, so basically this guy can't read a graph that isn't linear.
But actually, they don't observe the expansion of the universe. They observe the redshift of starlight,
which correlates strongly with distance and, due to the Doppler effect, indicates the recession of the galaxies from which the light is originating, meaning that nearly all galaxies are receding, and that the farther away they are, the faster they are receding. I don't know what Dr. Mortensen would call that, but I think the word expansion would be a decent word for it.
Well, what's that? Well, if you look at a light source in the laboratory through this apparatus, a collimator and a spectrometer, it will spread out the colors of the light spectrum, and it produces spectral lines. If you look at an object out in space through the same apparatus, it will produce a spectrum, but those spectral lines will be shifted usually towards the red end of the spectrum. Some objects are blue shifted, but most objects are redshifted, and they're not all redshifted the same amount.
Yup, and it's interesting that when we use standard candles to determine the distance to objects independently of their redshift or blue shift, it just so happens that only the closest ones, such as the Andromeda Galaxy, are blue shifted.
Well, what does that mean? Well, Edwin Hubble, after whom the famous Hubble telescope was named, interpreted that fact of redshift in the 1920s as evidence of the expansion of the universe.
Do you have any good reason to say it's not? You better have a good explanation for this wavelength shift if it's not due to recession.
And he concluded that the greater the redshift, the farther away the object is, and the faster it's moving away from us.
Well, the fact that higher redshift means a faster recession is a fact that has been verified experimentally through observation of light in particle accelerators. This isn't a guess. The distances of these objects have been independently verified through the use of standard candles. So neither of these are just a guess, they are facts. You need to accept and deal with that if you don't want to live in a fantasy. Of course, you do want to live in a fantasy, so I understand why you don't accept them.
Kind of like the Doppler effect, which you're aware of. If you're sitting in your living room and you have the draperies closed and you hear a police siren, you can tell that that police car is coming near your house, and you can know when that car passes your house and keeps going the other way because the pitch of the siren changes. And so the idea is that redshift is like that redshift means that the object is moving away from us, and blue shift, it's moving towards us. So they haven't observed the expansion of the universe. They've observed redshift, and they interpret it as evidence of motion. But that may be the wrong interpretation.
No, it's been experimentally confirmed to be caused by motion. It was a prediction of relativity, and it has been confirmed by numerous experiments, including highly accurate and precise experiments in the last few years. This is no more an unsupported interpretation of recession than actually watching that cop car shrink into the distance is an unsupported interpretation of recession. After all, just because it looks like it's getting smaller doesn't mean it's going away from you. Maybe it's just magically shrinking. Or maybe you're an idiot.
It's not proven to be the correct interpretation. It's assumed to be the correct interpretation.
You're wrong. It's so wrong.
Wrong, 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 wrong. Wrong, 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 wrong. You're wrong. You're wrong. You're wrong.
Well, what's the next line up in the chart? Well, that's the limit of indirect observation, which means that they've got to make a bunch of assumptions to add to their observations. Well, if that's the limit of direct observations and then the limit of indirect observations, what's the rest of the chart?
Inference based on our understanding of physics, which is tested by making predictions based on what new data we should see if these inferences are accurate. So far, they seem pretty accurate.
Well, that's not based on any observations at all, because we've already used those up.
No.
It's based on the observations we do have, just like when an investigator uses blood splatter and a coroner's report to reconstruct a stabbing he cannot see directly.
That's pure imagination, based on anti-biblical, naturalistic, atheistic assumptions.
Wow, talk about emotionally charged. But if the assumption that the universe operated in the past according to the same principles that operate in the present is atheistic and anti-biblical, then I guess science is atheistic and anti-biblical. I don't happen to think it's either, at least not in principle. And if it turns out that, yeah, the core assumption of science, which is the only reason science actually works and makes progress, is bad for your religion, then your religion is wrong. That's on you to fix. And as a heads up, there are plenty of Christians who manage to not reject the very basis for science, as well as its conclusions. So maybe consult with them.
Sir Fred Hoyle is a very famous astrophysicist. He died in 2001, famous English astronomer. He was an opponent of the Big Bang and actually coined the term Big Bang. It was a term of derision. He said, "Science today is locked into paradigms. Every avenue is blocked by beliefs that are wrong. And if you try to get anything published by a journal today, you will run up against a paradigm or a model, and the editors will turn it down."
You know what's fun about Fred Hoyle, besides having been proven wrong about most of the things he said about cosmology?
It's that he thought that one of the best reasons to reject the Big Bang was that it was too tied up with the ideas that correlated with Abrahamic religions like Christianity. In fact, he said the main reason it was popular is that most scientists like Genesis too much. I'm not sure if you want to rely on a discredited scientist who thought that what you're arguing against was too biblical. But hey, it's your speech.
You've maybe heard this. It's often said by evolutionists. They say creationists aren't real scientists because they don't publish their research in the peer-reviewed scientific journals.
People might say that, and it's a valid criticism that you don't publish except in trash journals that will publish about anything that confirms their bias. But really, you're not scientists because you reject the very basics of how science works, as you've demonstrated over and over in this very talk.
Well, that's false. They do publish their scientific research in peer-reviewed journals. They just don't publish their obviously creationist research in those journals because it's not going to get past the editor.
It's not going to get past the editor because it's laughably wrong about virtually everything. I'm sorry that young Earth creationism is on about the same level as flat Earth in terms of being concordant with the evidence, but that's not the fault of the editors of journals. The fact is that no creationist paper can pass peer review because it's wrong, not because editors are big meanie heads.
But they do publish other kinds of research in those journals.
Yup. When creationists don't invoke untestable miracles and don't use lies, they can and do publish in peer-reviewed journals. In other words, when they do real science. If anything, this is evidence that the peer review system doesn't much care who the author is. It cares about the science being reported on.
Well, Harton Alt is another world-famous astrophysicist.
He's so famous, I haven't heard of him and can't find him online. But then, I'm not sure how to spell his name. Maybe that will change if you bother to show his name on screen since you're referencing him.
He was an American atheist and also an opponent of the Big Bang. He said, scientists, particularly at the most prestigious institutions, regularly suppress and ridicule findings which contradict their current theories and assumptions. Astronomers now feel compelled to fit the observations to the theory and not vice versa.
Ah, there we go. Now I can find him. And what do you know? He based his ideas that expansion was not real on the statistical artifact that at the time of his work, many quasars were in close angular association with galaxies, and that the redshift of these galaxies and quasars did not match. Of course, now that we have orders of magnitude more data, his hypothesis that redshift was both quantized and did not correspond to distance has now been thoroughly discredited. And it already had been when he made this quotation, and that was already 20 years old when you told us about it. In fact, this quote is more likely the bitter complaint of a man whose pet ideas were not supported by evidence than some sober reflection on the state of cosmology.
In other words, Big Bang thinking is controlling how people see things and interpret things. So, let's summarize then. Regarding the origin of the cosmic egg, well, that was unknown and an uncomfortable question.
And now we have hypotheses. But even if the origin of the energy at the beginning of the Big Bang is mysterious, it doesn't mean that the Big Bang did not happen. You can have a hypothesis about how something changed over time without knowing where it came from. For example, if you saw a car crash, you could use things like tire marks, collision patterns, broken fences or guardrails, etc., to tell you a whole bunch about how that car crash happened. But if you don't know what address the cars started at that day, it doesn't make you wrong about the crash.
Regarding something coming from nothing, well, that's a scientific absurdity.
Well, you don't know that, and even if you did, the Big Bang doesn't require anything to come from nothing.
The origin of the moon is unknown, the origin of the solar system is unknown, the origin of stars and galaxies is unknown, so the Big Bang, I submit that is an unbelievable myth.
No.
Even if you were right about that, which you're not, it wouldn't have anything to do with whether the Big Bang were right or not.
Well, what about the age of the universe? Well, let me answer that question by asking another question. How old am I? This is an opportunity for audience participation. Would anybody like to guess my age? And there's no penalty if you get it wrong.
I don't know, about 50 or so. I don't really care.
Anybody? Yes. What's that? 59? Anybody else? 53? 63? 63? What's that? 42. That's 43. That's very kind, but wide of the mark. Well, actually, you were pretty close. I'll be 65 this summer.
Man, mammals are weird. You guys age funny. I still don't care, though.
But I don't always look my age. Sometimes that's an advantage, sometimes it's a disadvantage. But listen, wait a minute. How do you know that's correct?
I don't know it's correct. And if we were going to assume a lack of any documentary evidence, we could do things like test your bone porosity, tooth wear patterns, skull sutures, etc., and come up with an approximate age. But I'm sure that would be historical science or something.
What if God supernaturally created me a half an hour before I came into this room?
Then either he supernaturally created you to look exactly like you're of some age, and it doesn't matter because in every way that we can test you are a particular age, or you are anomalous and evidence for some kind of miracle. If the latter, that'd be pretty darn cool, but if the former, you're nothing special as far as anyone can tell, and you're not evidence for spontaneous creation of humans a half hour ago.
See, every one of your estimates on my age, you were making an assumption. You were assuming that I came into existence the same way you did and everybody else you know. You were making naturalistic assumptions.
Yeah, because those are the only kind of assumption that are testable. And it's also the case that we only know of one way for humans to come into existence, and it's not spontaneous creation of adults. So until presented with evidence that such an option exists, it's irrational to take it seriously. Are you saying that being rational is a bad thing? I mean, you must be, since that's basically the whole point of this talk, but it's odd to hear you being so blunt about it and thinking that it makes you look good.
But if God supernaturally created me, he'd be completely wrong.
Yeah. Did he, though? Do you have any evidence you didn't grow from a zygote the way the rest of us did? And by us, I mean basically all multicellular life? Because unless you do, it's stupid to assume you didn't, or even entertain it as a reasonable possibility.
If you don't know how I came into existence, you can't possibly know when I came into existence.
But I do know how you came into existence. Because there's a lot of evidence that you resulted from a zygote that itself resulted from sexual intercourse between humans of opposite sex. And even the other options, like artificial insemination or in vitro fertilization, are not exactly options that would allow your physical age to be so dramatically different from your actual age that you could be a half hour old.
Because the evolutionary estimates for the age of the universe are based on the same naturalistic assumptions that go into the Big Bang for explaining how the universe came into existence, but we see they don't know how anything came into existence.
Well, you're just wrong about that. And are you going to now argue that God made the universe a few thousand years ago and it just looks like there was a Big Bang? Because first, there's no reason to think that, because there's no way to differentiate that universe from one that was formed by a Big Bang. And second, the Big Bang retains its explanatory power. Also, of course, it makes God a liar, and an omnipotent liar isn't the sort of thing you really want in your epistemology.
Now, I don't always trust Wikipedia, but I do trust them pretty strongly whenever they're talking about evolution, because the articles are written by evolutionists and the footnotes are in the technical peer-reviewed literature. Calculating the age of the universe is accurate only if the assumptions built into the models being used to estimate it are also accurate.
Good thing those assumptions can and are tested. But even if they were inaccurate to some degree, it's certainly not to the degree that could allow for a creation only a few thousand years ago. At the very least, the universe can't be any younger than Earth, and that is certainly a few billion years old, which puts a lower limit on the age of the universe.
Well, they've got this chart with it, and you can see at the very beginning, the earliest universe down at the bottom, earliest gravity, then earliest light, cosmic expansion, dark matter, dark energy, which they don't know what that is. And then you've got the first single-celled creature and photosynthesis and multi-celled creatures, and eventually man. The article goes on, in physical cosmology, the age of the universe is the time elapsed since the Big Bang. See, they've just assumed that the Big Bang is true.
No, it's been well demonstrated. The universe is expanding. It was smaller. Numerous predictions of the Big Bang have been verified. It has yet to be falsified, and current physics knows of no way to not have the universe start with a Big Bang given its current expansion. The Big Bang isn't an assumption.
Measurements of the cosmic background radiation,
the cosmic microwave background radiation that should only be there if there were a Big Bang, and that is otherwise inexplicable? Okay.
give the cooling time of the universe since the Big Bang, because they assume that the universe has been expanding and cooling at a certain rate.
Again, not an assumption. It's a measurement. A measurement cross-confirmed by various standard candles and redshift measurements. Maybe to a creationist, assumption just means thing we've shown to be true with high confidence.
And measurements of the expansion rate of the universe can be used to calculate its approximate age by extrapolating backwards in time. Well, they're making some more assumptions. They're assuming that even if the universe is expanding right now, that it expanded from a simple point.
That's not an assumption either, at least not anymore. There is evidence for it, some of which you just mentioned, and it's also the logical consequence of the expansion of the universe, since when run backwards, that results in an ever-decreasing scale of the universe.
What if it was made just a little bit smaller than it is now and it's expanded since then?
Then there would not be a cosmic microwave background, the apparent age of galaxies would not correspond so closely with their distance, and there would be no reason to expect redshift and distance to correlate so strongly. And we wouldn't be able to see farther than a few thousand light years. In other words, unless God lied about it, the universe wouldn't look as it does. The thing is, the universe do what it do, and what it do is be old.
You see the assumptions hidden?
Well, nothing's hidden, and the only assumption is the assumption that physics isn't magic, and that neither are things in space. The things you listed are not assumptions, but conclusions based on volumes of data, which are then used to make future predictions and determinations.
A new estimate of how fast the universe is expanding supports one side of an ongoing debate favoring a more rapid expansion. Observations of type 1a supernovas imply a faster expansion rate, known as the Hubble constant, than studies of cosmic background radiation.
Yeah, this is a fairly recent finding, and currently the new age is seeming less likely. But neither option results in an age for the universe that's within 5 orders of magnitude of what you're suggesting it is. So whoever turns out to be right, and whatever that means for the datasets that seem to imply the other ages, you're wrong. You don't get to quibble over the difference of a few billion years when your suggestion is orders of magnitude outside the realm of possibility. It's like people arguing over whether the drive to the next city over is 10 or 12 miles, while you're there saying it's a bit under a foot. You are simply not part of that conversation because your suggestion is so ludicrously wrong that it's barely worth even noticing. That's why it's left to people like me to interact with it, because the adults in the room are busy doing real science.
If the disagreement persists, it could indicate something amiss in scientists' understanding of the cosmos.
Yup, and that will prompt refinement of cosmological theories. And I guarantee you, it won't shrink 10 miles into 10 inches, and that's what you need it to do to be right.
Perhaps related to the mysterious dark energy that is accelerating the universe's expansion. But when we think about the origin or the age of the universe, there are some objects that lead us to believe it's not anywhere close to what the evolutionists say.
Ooh, that sounds like you're going to actually offer evidence for your position rather than quote-mining scientists and pretending that disagreements about the exact age of the universe within the scope of a few billion years can make an age of a few thousand years reasonable. This should be interesting.
As far as our solar system, which is said to be about 5 billion years old, there are short period comets.
Okay, I'm pretty sure I know where you're going to go with this, and I plan to debunk it when you get there, but the age of the solar system and anything in it puts a lower, not an upper age limit on the age of the universe. The universe can't be younger than the youngest thing you can find, but it can be much older. If the whole solar system were 6,000 years old, that wouldn't mean anything for the age of the universe.
Short period comets go around the sun every less than 200 years. Long period comets take longer to go around the sun. But every time a comet goes around the sun, it's going in a very, very elliptical orbit, and it gets quite close to the sun on one part of the orbit. And when it does, the heat and the energy coming from the sun melts some of the ice, breaks off some of the rocks, and that comet's only going to go around the sun so many times before it's the last lap. It's blown to smithereens.
That's a pretty good explanation. I have no particular argument with you so far.
And Halley's Comet makes that path every 76 years. And it's not going to last forever. There's a problem. we have comets in our solar system. And if our solar system was really 4.5 to 5 billion years old, there shouldn't be any comets. They should have all been destroyed.
Speaking of hidden assumptions that you like to complain about, Dr. Mortensen, your hidden assumption is that current short-period comets are primordial. If we have reason to think that they are not, such as knowing about much older objects than comets, or if there were some source for long-period comets that can become short-period comets, then this argument falls flat on its face.
And so the evolutionists have come up with two explanations for where more comets can come into the system. One is the Kuiper belt, which is just past the orbit of Neptune, and there are objects out there, but they're too large and the wrong composition. And then there's the Oort cloud, which is said to be past the orbit of Pluto.
In fact, the Kuiper belt is not made up of only large objects. It's just that those are the easy ones to find, since they're the ones that reflect the most light. And their composition is not wrong, it's perfectly fine being mostly made up of volatiles. It's just that as a short-period comet orbits, it will lose the lightest and easiest sublimated volatiles first, and so over time its composition will change from its original. And yes, the Oort cloud is another pool of icy bodies that are primarily small and could be disturbed into a lower orbit. But its distance from the Sun makes it more likely a source for short-period than long-period comets.
But it's never been observed. They've never observed anything out there.
It's true that direct observation of the Oort cloud is currently lacking, but until you eliminate the possibility, then the combination of verifiably old objects in the solar system with the presence of short-period comets makes its existence a far better option than, even though the solar system is old, it's not old, which is basically the option you're asking us to consider, Dr. Mortensen.
So it's just assumed, and then they've got the problem of explaining how you knock these things into orbit.
They're already in orbit. They only need their perihelion lowered sufficiently. And that's the kind of thing that happens after a close flyby with another body of sufficient mass. In other words, gravity and orbital mechanics is how it happens. Do I have to bring out more Kerbal Space Program footage? Because I will if I have to.
Well, if you want to know more about the problem of comets for the billions of years, we have an article on our website, and you can look at that further. Recently, a space probe going by Pluto took close-up images of a region near Pluto's equator, revealing a giant surprise, a range of youthful mountains. See, what they observe is surprising them because they have an evolutionary assumption of long ages.
No, it surprised them because they thought that Pluto would probably be rather inactive geologically, but that seems not to be the case. Fortunately, there are plenty of options that can make small, cold bodies geologically active, such as tidal forces.
Then, if we go farther out in space, we have spiral galaxies. And the arms of these spiral galaxies should not exist if these galaxies are billions of years old. That is because they are spinning, and they should be, after billions of years, should be an unrecognizable blob of stars. The arms shouldn't be there anymore.
Except that the arms are more or less standing waves of pressure and not physical structures made of a particular group of stars. As such, they do not rotate at the same average speed as the stars in the galaxy. And in fact, the speed at which they do rotate is more uniform than the speed of the stars in the galaxy as a whole. So no, they shouldn't be gone if galaxies were billions of years old. You just don't know the first thing about galactic spiral arms.
Danny Faulkner on our staff is a PhD astronomer, taught at the university level for over 25 years, and he has an article on that if you want to learn more.
Maybe sometime I'll look into that article, but for now I'm sticking with your presentation in this video.
In our books, the Answers books, Volume 3 has a chapter on some more evidences for a young universe. In Chapter 1, we've got a chapter on does distant starlight prove the universe is old? This is a very common objection.
Look, I have no problem really with you showing your stuff. I do it too. But I really don't care about what's going on with your publications and presentations outside this video. I'm here for this video. That's it. Either you can give the arguments yourself, or I just won't hear them during this series.
How can we see stars and galaxies that are billions of light years away if the universe is only 6,000 years old?
You can't unless God is constantly lying to you. Those are the options.
If you've got that question, that would be a good book to get and a chapter. Or you can read it, an article, short article on our website. And what the article and chapter show is that creationists have proposed several explanations for this, but they don't have solid answers. But the evolutionists also have essentially the same problem.
You don't have any answers, and the science says that things are at least as old as they have to be for physics to work. I'm not sure what the problem here is.
They can't explain how light got distributed throughout the universe to produce the uniform background radiation temperature.
I feel like you weren't paying attention when you were talking about things like cosmic inflation and the cyclic hypothesis earlier in your speech, because both are options to explain the high degree of isotropy in the CMB. But the bare existence of the CMB is only explained by the Big Bang. You don't get to say that because I can't explain exactly what brand of knife was used to kill a murder victim, it means that the murder didn't happen, while you're standing on the scene with the body in front of you. And yes, I'm going to keep making comparisons to forensic science because creationists, generally, do not reject it.
So, creationists don't have a good answer for that question, but neither do the evolutionists. Well, let's turn to what the Bible says, because the evolutionists don't know how anything came into existence in the universe.
Well, scientists do, whether you ignorantly call them evolutionists or not. And we can't turn to the Bible because, as I said during an earlier video in this series, you have to test your interpretation of the Bible against reality, or you can't tell if your interpretation, or the Bible as a whole, is true. Reality as it exists is prior to the Bible, and if the Bible or your interpretation thereof contradicts reality, reality wins.
So what does the Bible say? Well, the Bible says in Psalm 33 that by the word of the Lord the heavens were made, and by the breath of his mouth all their host. For he spoke, and it was done. He commanded, and stood fast. Lots of Christians say the Bible tells us that God created. It doesn't tell us how God created. Well, it most certainly does. 10 times in Genesis 1 it says, and God said. And right here it says, God spoke things into existence.
So your claim is that before there was matter, a God with no physical form caused pressure waves in the non-existent matter in order to speak some language of which there were none at the time, and that this is an explanation of how the universe came into existence that should stand alongside scientific theories about the same? If taken literally as a sufficient answer, that's not even a coherent idea. It's actual nonsense. You might as well say God made a square circle out of water made of iron and then pushed the universe through the middle of the outside of it. Your claim means nothing if we take those words literally.
And he didn't say, let there be light, and then wait for billions of years for light to form.
What? Light was the dominant constituent of the early universe according to the Big Bang. It didn't take billions of years to form. There was so much of it that the universe was uniformly incandescent for quite a while.
He didn't say, let there be a sun, moon, and stars in the heavens and wait for billions of years. He spoke, and it was done.
That's not an explanation. That doesn't give us any information on what physically took place in the universe. Look, I don't really care for the purposes of this channel if God created the universe, the solar system, or anything else. But what you gave is a metaphor, not a physical description of the process of creation. Not because I think the Bible can't be taken literally, or that it's wrong when it is, but simply because it can't possibly be a physical description of the process. Speaking doesn't do that, so something else must have happened even if God did create the universe. But at least you're not in a period where even according to your ideas, speaking is a thing that's impossible to do, since there are now media for the sound waves God is presumably making by speaking.
Psalm 19 says, the heavens are telling of the glory of God, and their expanse is declaring the work of his hands. The heavens do declare the glory of God.
Maybe, but if they do, then it's a God that created a universe via a Big Bang.
And we see order and design. We see constellations. And as long as people have been looking up at the heavens, way back to the ancient Chinese, in the northern hemisphere, they've seen the same constellations that we see.
The stars and constellations drift according to the star's proper motion. All the main stars making up the shapes of the constellations have such small proper motion that we should not have seen any drift in that time frame. This is concordant with both standard scientific models for the origin and current state of the universe and galaxy, and with spontaneous creation. You cannot use this fact to distinguish between these propositions.
It looks designed. It looks orderly. Things are moving in an orderly fashion. And it reveals that the Creator is a lawgiver, that He is orderly.
It's a random assortment of dots of random brightness, all of which are following the law of gravity to orbit the center of the galaxy. It's about as disorderly as it possibly could be. Your ability to find patterns that do not objectively exist means nothing, nor does the time span of human civilization being too short for major changes in the position of stars in the night sky to have occurred mean anything.
And, explosions don't produce design.
Well, there's no evidence that the universe was designed, and the Big Bang wasn't an explosion, so you managed to get two things wrong in one sentence. I think you can do better.
If an engineer has an explosion in the lab, he's not going to win a Nobel Prize. Explosions produce lack of order. Design is produced by an orderly mind.
Look, if you want to argue that a bunch of matter following the laws of physics in completely natural ways, that are completely consistent with them all having coalesced out of essentially random initial starting conditions, indicates design, I guess you can. But at that point, everything would be designed, and the idea of design stops being meaningful, because we can no longer use it to distinguish any class of objects from any other. Is the sand on the beach designed? What about the waves on the ocean? What about a Jackson Pollock painting? Well, under your idea that anything is designed, I guess sure. But in fact, all of these things were created without any particular end in mind. And there was clearly no intelligent act or forethought in any of them.
Well, then let's look at the fourth day. Genesis 1, God created the sun, moon, and stars. He said, "Let there be lights in the expanse of the heavens to separate the day from the night. Let them be for lights, for signs, for seasons, for days, and for years. And let them be for lights in the expanse of the heavens to give light on the earth." And it was so.
I mean, really only the sun does any of that, so it seems that the stars and the moon are unexplained. And the moon isn't a light. Well, unless you're one of those flat earth, cold moonlight lunatics. And since you're a young earth lunatic, you might as well be.
Now, the phrase there in green, that's just one of many evidences that these are literal days. Because he says why he created the sun, moon, and stars. It's so that people could measure years and seasons and days. And the movement of the heavenly bodies do enable us to measure literal years, literal seasons, and literal days.
Okay, I'm not endorsing a day-age interpretation of Genesis 1, or any other interpretation. But why does this mean that the days had to be literal days of creation? Couldn't God create the sun, moon, and stars for that purpose over the course of billions of years? Why does their intended function for humans dictate the timescale of their creation? I really don't get this argument.
But then you have those phrases in yellow. And "let there be" appears 10 times in Genesis 1. "And it was so" appears 7 times. And "God saw that it was good" appears 7 times. And here's a simple principle of Bible study. When you see God repeating himself, you should say, "Aha, I think he's trying to emphasize something." And those phrases all together emphasize that when God spoke things into existence, they came into existence, and he declared them good before he went to the next day to make something else supernaturally.
Okay, let's say that's the correct interpretation. Do you have any evidence of a sudden appearance of the universe ex nihilo in the last few millennia outside of that book? Because, spoiler alert, you can't use any book as evidence in science. Evidence in science comes from observations of the universe, not books, except that observations may be recorded in books. But the book doesn't even claim that anyone observed the first few days of creation, and since the only evidence we have for the existence of Adam and Eve are in that book too, no one verifiable observed any of it. So nothing in there is useful to science. That doesn't make it wrong. But it does mean that if you want to say it's scientifically accurate, you have to get corroborating evidence. And there just isn't any evidence to support the historicity of your interpretation of Genesis.
On the day 4, in verse 16, we read, "God made the 2 great lights, the greater light to govern the day and the lesser light to govern the night. He made the stars also."
What's the lesser light? If we're going to take all of this literally, it can't be the moon, because that's literally just a hunk of rock in space. It doesn't give off any light. It just poorly reflects light from the sun.
Now at this point, Christians who accept the Big Bang and want to believe in billions of years, they will say, "Oh, did you see that second word 'made'? In your Bible, it's in italics." And if you open up the front of your Bible, the editors that produce that translation will tell you that anytime you see a word in italics, it means there's no Greek or Hebrew word behind that English word. It's been inserted by the translators. And so, see, the verse doesn't say that God made the stars. Oh, yes, it does. And the reason that it's in our English Bible is because the Hebrew requires it. There's a little Hebrew word in that verse that appears 4 times. It's not translated, but it's a direct object marker in the Hebrew language.
Yep, I'll agree. If you want to use that argument to say that the verse doesn't say that God made the stars, you're wrong. It does say that. I'm cutting out the rest of this argument because I don't contest it. Okay, for the next 4 minutes, Dr. Mortensen argues that his interpretation of Genesis is correct, and since I don't care about that argument, I'm skipping it. If Dr. Mortensen wants to interpret the Bible in a way that makes it wrong, that's his business.
So the Bible clearly teaches that the sun, moon, and stars were all created in day 4. There's another problem with trying to harmonize the Bible with the Big Bang Theory, and that is that the order of events in the evolutionary story contradict the order of events in the Bible.
That's one of the reasons that people have come up with phenomenological interpretations for Genesis. It's because since we know the Big Bang is correct with way more confidence than we have about anything in the Bible, or anything in history in or out of the Bible up until the modern era, then the Bible needs to conform to the Big Bang, not the other way around. And if it can't, it's just wrong. Kinda means maybe you shouldn't have spent all that time I skipped arguing against anything other than interpretations that make the Bible wrong.
So you've got the Big Bang, stars forming before the sun. Our Earth was a hot molten ball that came from the solar gas cloud and eventually cooled and developed a hard crust and then evolved an atmosphere, and it rained and asteroids slammed into the Earth and we had oceans.
It is odd that of these, only really the first of your pictured events counts as the Big Bang. Then you moved on to stellar formation and planetary formation. These things are not dependent on the Big Bang. But I guess if you didn't conflate things, you wouldn't really be creationists.
According to the evolutionists, there's never been a global ocean on this planet. But the Bible says God made the earth before the sun, moon, and stars, and it was completely covered with water for 2 days. And then he made dry ground and all the land plants, and then he made the sun, moon, and stars.
Well, when you bring forward evidence of a global ocean, scientists will look into it. You haven't, and there's good evidence against it ever happening, never mind happening twice as you believe, once during the creation week and again during the flood.
So according to the Bible, peanuts have been in existence longer than planets, and grapes have been in existence longer than galaxies by 1 day.
And that doesn't strike you as stupid when you take it literally? I mean, okay, sure, but maybe don't make that a big talking point because I'm pretty sure people will just laugh at you if you try to convert them with that.
You can't harmonize the Bible with the Big Bang, no matter how much time you put in there.
More's the pity for the Bible.
But, there's something else that's significant. I have noticed of all the Christians that I've interacted with or read about who accept the Big Bang, they believe what the Bible says about the future of the universe, but they don't believe what the Bible says about the past, about the origin.
The future is, conveniently, not around yet, so you can believe whatever interpretation you want, and as long as you don't put a date on it, you'll never be shown to be wrong. So it's not surprising that people have to constrain their interpretation of text to conform to what we know about the past, but that they don't really have to do so about the future. But then again, I know Christians who'd almost certainly disagree with you about what the Bible says about the future. For instance, I'll bet you believe in the rapture based on where you work. But it might surprise you to know that that's a fringe doctrine invented in the 19th century. It's unknown in Catholicism, Orthodoxy, Lutheranism, and traditional Calvinism, or at least it is denied by the officialdom of all those churches. So perhaps this agreement on biblical predictions about the future is overstated.
You see, the evolutionary view of the universe isn't consistent, of its future isn't consistent with the Bible either. In the evolutionary view, there's a couple of scenarios. One is that gravity is going to take over on that expansion, and we're going to have a big crunch.
Gravity has nothing at all to do with evolution. Can creationists please stop conflating basically all of modern science with evolution?
And then we might have another big bang, and then another big crunch, and then another big bang.
Yeah, except even when you gave this speech, we knew the universe was either flat or slightly open, and so the big crunch isn't a possibility.
Or the universe is going to keep expanding, stars are going to explode in supernovas, and eventually it's going to take a long time, so you don't need to worry about it personally, but all of the stars will become dead. The universe will become nothing but cold, random atoms.
Yep, that's probably what will happen. Although if there's a supernatural intervention to stop that, I won't complain.
But the Bible says there is going to be a heat death, but it's going to be a literal heat death. And then there's going to be a new heavens and a new earth.
Well, when the universe dies in the burning flames of a loving God, then we'll know. But since that's not exactly a predictable event, we're going to go ahead and stick with what is predictable when talking about the future. You know, the way of talking about the future that has proven more accurate than any other way of doing it.
So all the scientists have the same facts. They have the same stars and galaxies and the same planets and the same stardust. If they start with naturalistic assumptions, they come up with the Big Bang in billions of years.
Yup. When you start with the assumptions of science, science leads to the Big Bang. And since if scientific assumptions were badly flawed, it would mean that science is unreliable. And since science is obviously extremely reliable, they're good assumptions for science. Sorry that upsets your apple cart of ideas believed against the evidence.
If they start with biblical assumptions, looking at the universe, they see all kinds of evidence for design in a young universe.
No.
No scientists look at the evidence with biblical assumptions, because those assumptions, even if correct, aren't scientific. So if you start with them, what you're doing isn't science. If science ends up backing up your biblical assumptions, then bully for you, but it still wouldn't make them scientific assumptions.
The Big Bang is false because the naturalistic assumptions are false. Well, so what? Does it really matter?
Well, the Big Bang isn't false, but I mean, does it matter? To your life as a human on this rock? No, probably not. Your life would probably go on as it is now if we knew nothing about the Big Bang. On the other hand, if you have a curiosity about the universe around us and how it came to be as it is, then it matters, because it is at least broadly correct.
It does. And I want you to listen to the words of Lawrence Krauss. He's one of the most famous astrophysicists in America, professor at Arizona State University, and a very outspoken, aggressive atheist. He's speaking at he's giving a lecture at a conference for atheists, and I want you to hear what he says.
Okay, I'll listen to him. Somehow, I don't think he'll change my previous statement, though. But hey, he's smarter than I am.
The amazing thing is that every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than your right hand. It really is the most poetic thing I know about physics. You are all stardust. You couldn't be here if stars hadn't exploded, because the elements, the carbon, nitrogen, oxygen, iron, all the things that matter for evolution, weren't created at the beginning of time. They're created in the nuclear furnaces of stars, and the only way they can get into your body is if the stars were kind enough to explode. So forget Jesus. The stars died so that you could be here today. Okay? And anyway.
So forget Jesus. The stars died so you could be here today.
So the Big Bang matters because our largely unrelated theory of nucleosynthesis allowed someone to make a joke about Jesus. I'm honestly not seeing why that means the Big Bang matters, except for purposes of satisfying intellectual curiosity.
Well, Lawrence Krauss is a very, very smart man. I'm a mental midget compared to him. But I submit to you, that is foolish arrogance.
I'm not sure telling a joke counts as arrogance. You know, not everyone who doesn't believe what you do does it because they're arrogant. And the only reason why someone might have some taboo against joking about Jesus is that they believe in him. And since most people don't, most people lack such a taboo, no matter how arrogant or not they are.
The Bible says the fool says in his heart there is no God. The fingerprints of God are all over the creation. And he doesn't know that the atoms in his left hand came from one star that exploded, and the atoms in his right hand came from another star that exploded.
Yeah, that bit was put in there to emphasize the scale of the discussion. I doubt anyone took it overly literally, but then you're the type who has been shown to like to take things overly literally. So I'm not surprised you did it in this case.
I do agree with one thing he said in that statement. He said this is the most poetic thing he knows in physics. That's poetry. That's not science.
The bit about the hands in Jesus is poetry, not science. But nucleosynthesis is very much science.
Well, you remember I talked about Neil deGrasse Tyson in that Cosmos series in 2004, watched by millions of people. It's now been produced into a really classy curriculum for the public schools and used in not only this country but other countries. In the 8th episode, he says this for high school students to ponder.
Our ancestors worshipped the sun. They were far from foolish. It makes good sense to revere the sun and stars because we are their children. The silicon in the rocks, the oxygen in the air, the carbon in our DNA, the iron in our skyscrapers, the silver in our jewelry were all made in stars billions of years ago. Our planet, our society, and we ourselves are stardust.
Yeah, again, he's being poetic. I don't think he honestly thinks that humans ought to worship the stars or the sun, or that you are their biological offspring. He's just pointing out their role in nucleosynthesis, which is a prerequisite for the formation of bodies composed of relatively high-mass nuclei, like Earth.
Did you hear what he said? Our ancestors worshipped the sun. They were far from foolish. Makes good sense to revere the sun and stars because we are their children.
People worship what's important to them, and it's hard to find a culture for whom the sun wasn't important, and with good reason.
You know, you open the Bible and you read about the people of Israel, the ancient people of Israel, and you read about the New Testament times and the Greek philosophers, and these people worshipped idols. Well, you know, the Egyptians worshipped the sun. And we might, in our arrogance as modern Americans or modern 21st century citizens of Earth, we might think, how ridiculous that people worship these things. We still have idolatry going on today.
Yeah, I'm pretty sure Neil deGrasse Tyson isn't worshipping the sun or actually encouraging the youth of the world to do so. It's a ball of mostly hydrogen. It doesn't care about your worship or lack thereof, and he knows that.
Well, I want to finish with one more little clip from an astrophysicist, an astronomer at NASA.
So what is human existence? How can you actually sum it up? It turns out it's really pretty simple. We are dead stars looking back up at the sky.
Dead stars looking back up at the stars. If you teach children that they're just stars that have died and exploded, if you teach them that they should worship the stars.
No one is teaching kids to worship the stars. Also, I want to point out the bad audio sync is in the original video. It's not my fault.
They're not going to come to the conclusion that they have any purpose or meaning to life. They're going to come to the conclusion, I'm the result of a long series of 13.8 billion years of time and chance and the laws of nature. I'm an accident.
No matter if there's a God or not, or if the Big Bang is true or not, or if nucleosynthesis is true or not, or if the nebular hypothesis is true or not, or how the first life formed, or if evolution is true or not, purpose must always be self-derived. Even if God had a purpose for you in mind, and if he doesn't or doesn't exist, you still have to accept purpose for yourself, or not. Purpose is the product of a mind and doesn't exist as an objective phenomenon in the world. It's not always easy to accept, but even if Christianity is true, you still need to find your purpose for existing inside you. Sure, your religion can help guide you in that, but either way, it's going to be your decision. And the sad fact is that you can choose not to have a purpose. But happily, most people don't choose that. Most of them live lives of purpose regardless of their belief in God.
There's no right or wrong. There's no God to whom I'm morally accountable.
There are many moral philosophies which do not require there to be a God, but which make claims that things are in fact moral or immoral. Really, all that's required for a moral system to be objective without a God is a goal in mind and a reasonable way to determine if various acts work for or against that goal.
Atheism is so senseless. When I look at the solar system, I see the Earth at the right distance from the sun to receive the proper amounts of heat and light. This did not happen by chance. This most beautiful system of sun, planets, and comets could only proceed from the counsel and dominion of an intelligent being. Who said that? A scientific ignoramus? Somebody who is just a Bible-thumping Christian who doesn't know anything? No, it was actually said by a man who is considered by many to be the greatest scientist who ever lived, Sir Isaac Newton.
Shocker! Man alive before modern discoveries in astronomy was unaware of modern discoveries in astronomy. You also know the dude drank mercury, right? In fact, he got pretty crazy late in life, quite possibly as a result of mercury poisoning. Maybe quoting someone who couldn't possibly know what we know now about how impossible the solar system is to come about naturally doesn't really matter, since he couldn't have the information to make such an assessment.
So most of the scientists say the Big Bang happened billions of years ago. Take my word for it.
No, they say, don't take my word for it. Here are mountains of observations, simulations, and confirmed predictions.
God says, I created the earth before the sun about 6,000 years ago. Take my word for it.
Well, if that's what he said, he certainly left behind every indication that it's not true, so no, I wouldn't take his word for it. But then I don't think that if a God exists, that's what he really said. Mostly because I'm not going to allow an omnipotent trickster as a possibility. Because, well, it's not pragmatic, and I'm more or less an American pragmatist philosophically.
Christians have to decide whose word they're going to take, but so do non-Christians.
Nope, they can just follow the evidence like science has, and realize that the Big Bang is as much a fact as the existence of atoms, gravity, or biological cells.
Because the question has eternal significance.
Really? Because I thought that according to you, the question with eternal significance was your acceptance of the sacrifice of Jesus Christ, not the origin of the universe. And since you can believe different things about either independently, I'm not sure how the Big Bang can be of eternal significance even in your theology. Okay, well, the rest of the speech is just preaching and then about 10 minutes of commercials for AIG products. Since I don't care about either, that's where we're going to end things. It's been a bit of a crazy journey, and I can't say I'm not glad to be moving on to something else. And that's something else my patrons on Patreon get to vote for. So if you hate what's next, blame them. But I don't think you will hate it. After all, you stuck with me through this.
Thanks for watching, but before you go, I'd like to take a minute to thank my patrons, especially my $20 patrons. Bent Hovind, Ian Chen, Bob Knob, The Evil Scotsman, Henry Hutanen, Chris Love, and Res Instance. My team over at Patreon are helping me make these videos, and I have tiers starting as low as $1 and going all the way up to $100. So if you'd like to help out the Dapper Dino channel and help make these videos better and possibly even more frequent, then why don't you head over there and check it out. If a recurring donation isn't right for you, but you'd still like to help out, I have a link to my Amazon wishlist in the description. I'm the Dapper Dinosaur.
So you found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on this.